Can AI be conscious? If by AI you mean the program as such, the software, the computation, the abstract pattern, then this isn't an open question. The answer is no. That claim isn't about silicon, neurons, or machines in general. It's about a very specific and very popular idea that first-person experience could be a property of code itself. That idea doesn't just lack evidence or seem unlikely, it relies on a category mistake. I'll explain what that mistake is in this video. You won't need computer science to follow the point. You'll only need one distinction, the difference between what something is in itself and what it is only under an interpretation, what we treat it as. Showing what's wrong with the idea of conscious computation won't answer every question about artificial consciousness, but it will rule out a number of confusions and teach us something important about what consciousness would actually require of a machine. By the end of this video, we will at least be in a position to say why that requirement is much harder to satisfy than the software consciousness picture suggests. Chapter 1. Setup. What question we're really asking, and what counts as an answer. People often assume that if AI falls short of consciousness, it falls short only by degree, not by kind. So they ask, what sort of problems would it have to solve? How smart would it have to be? How much like us would it have to seem? How unpredictable would it have to become?
Can a robot write a symphony? Can a robot turn a canvas into a beautiful masterpiece?
Can you?
But the real obstacle isn't an engineering milestone. It's conceptual. The question isn't whether a machine can do what we do. The question is whether a machine can have what we have, first-person experience. Before going any further, it helps to clear up a common conflation. The question, are AIs conscious, is often taken to ask, are they genuinely intelligent, with genuinely being the point of contention. Sometimes it means competence, but just as often it sneaks in a stronger demand, having its own ends and caring about them. Because teleology talk is often associated with hidden intentions or anthropomorphic projection, it's helpful to distinguish three layers of description that are easily conflated: ends, goals, and problems. At the most neutral level, we may speak of ends or functions. In this sense, an end is a role a component plays within a larger system under a characteristic range of conditions. The claim that a thermostat regulates temperature or that a model minimizes loss does not attribute conscious aims. It records a reliable pattern. Under the relevant operating conditions, the system's organization tends to contribute to a certain outcome, and counterfactually, had it not behaved as it did, the downstream outcome would not have obtained. Teleology at this level is evaluatively neutral. It describes what follows from what within a given structure. A stricter notion enters when we talk of goals. A goal isn't merely an end in this thin functional sense. It's an end that is to be brought about for some subject of experience. Here evaluation appears. Some possible states are to be secured and others to be avoided because they would be experienced as preferable or dispreferred. Finally, the language of problems and solutions belongs to a third layer. A problem, as such, isn't a mere divergence between two possible states. It's a state that obstructs a goal. A solution is one that, relative to a goal, removes an obstruction or advances what is sought. Once we call something a problem, we have presupposed a goal, and once we presuppose a goal, in the strict sense, we have presupposed an evaluative orientation. Something can count as better or worse for the subject. This distinction matters here because much AI intelligence talk slides back and forth across these layers. A system can be entirely competent relative to ends we assign, trained to minimize a loss, rewarded under a benchmark, while still lacking any intrinsic standpoint in virtue of which those ends count as goals for it, and in virtue of which anything counts as a problem for it from its own point of view. In that case, the system is functioning as a tool, and the evaluative structure, the sense in which some states count as better or worse, belongs to the user, not the tool. If someone replies that the tool does have goals because it's trained under a metric, the reply merely relocates the issue. An externally defined score can guide updates, but it doesn't by itself supply the evaluative standpoint in virtue of which higher counts as preferable and lower as dispreferred for the system. Without that standpoint, the metric is just a designer's control variable. And if one proposes to create that standpoint by training, by coupling behavior to the metric, one has simply assumed what one meant to explain. The metric can play the role of a goal only if someone already treats its increase and decrease as mattering. So I'm happy to grant that AIs can be highly intelligent and, in principle, may become generally intelligent or superintelligent in the instrumental sense. What I deny is that competence of that kind is already consciousness. Consciousness, in the sense relevant to this debate, requires some basis in experience. Some intrinsic standpoint for which the better-worse distinction isn't merely a score we compute, but something that can obtain for the subject itself. That difference between hitting a target and having one is exactly why behavioral success is at best a proxy for what we're really asking about. Fittingly, a useful comparison comes from reinforcement learning. Designers care about a target standard, finish the race, land the plane, minimize collisions, but they train the system on a proxy signal, a simple reward value that is easy to compute. When the proxy is well chosen, maximizing it correlates with the target. When it isn't, the agent can win by the proxy while obviously missing what the proxy was meant to track, looping forever to rack up points instead of finishing the race. The general lesson is structural. Success at a metric does not guarantee possession of what the metric was meant to track. And in the consciousness debate, behavioral tests, fluency, self-report, apparent emotions are proxies. They may correlate with consciousness in humans, but they don't amount to it, and they don't, by themselves, settle whether first-person experience is present. At most, they show that the system has learned to produce the patterns that in us are often downstream of experience. Whether anything is present upstream, whether there's something it's like, remains the constituting question. Consciousness is a many-purpose word. We call a person unconscious when they're in a coma. We call an action unconscious when it's performed inattentively. We call an inanimate object unconscious to mark that there's nothing it's like to be it. Philosophers then add further distinctions: state versus creature consciousness, access versus phenomenal consciousness, higher order versus first order accounts, and so on. I'm not going to settle those disputes here, because nothing in what follows depends on choosing among them. What I do need is a minimal constraint that makes clear what the present question is targeting. In what follows, consciousness means the sense at issue when people ask whether an AI might wake up or really feel something. Phenomenal consciousness, first-person experience. If there's no experience at all, no what it's like, then there's no consciousness in any sense relevant to this debate. In that minimal sense, to be conscious is at least to be sentient. One central feature of ordinary sentience is valence, or hedonics, pleasantness and unpleasantness, comfort and discomfort, attraction and aversion, which functions as a mediator between organism and environment. It translates dispersed conditions into a common currency of better and worse for the subject. That is why thick talk of goals, problems, threat, and relief naturally attaches to sentience insofar as it's valenced. Those categories presuppose that something can count as preferable or dispreferred for someone. Whatever else consciousness is, that for isn't supplied by third-person description or external scoring. To set a boundary condition, none of what follows is addressed to eliminativism about phenomenal consciousness, the claim that there is no further fact here, nothing over and above third-person behavior and the dispositions that produce it. If this position is adopted, it should be declared at the outset, because it's not a rival account of consciousness, but a refusal of the subject. Otherwise, it functions as a bait and switch. It borrows ordinary talk of pain and experience while denying there's anything for that talk to be about. The result is a hollow AI does what we do, where what we do has been defined down to nothing. That isn't engagement with the question, it's a change of subject. Given that minimal constraint, sentience as the least that consciousness could be, this immediately rules out one tempting shortcut. The target here can't be something that gets supplied from the outside by our classifications. If a subject is conscious, that fact would still be the case even if no one ever recognized it, tested for it, or even had the concept of consciousness at all. Our descriptions and tests may be evidence, they're not what would constitute experience if it were present. By contrast, many statuses we ascribe to things, counting as a signal, standing for something, functioning as a representation, are roles that obtain only relative to a practice of interpretation and use. Experience, if present, is intrinsic. Those role-like statuses are not. A simple physical analogy helps. Take temperature. If a grill is hot enough to fry an egg, it'll fry the egg whether I describe it as hot or cold, whether I believe it's hot or deny it. The heating is intrinsic to the grill's physical state. In the same way, if consciousness is present in a subject, it's present as an intrinsic fact about the subject, not as a label that our descriptions paste onto it. Before we go further, I'll specify the target in the sense used by the computational theory of mind, CTM. The usual slogan is that the mind is to the brain as software is to hardware, so when I say AI in what follows, I mean AI in the CTM sense, the computation itself, the abstract procedure or functional organization individuated up to the relevant kind of structural equivalence, rather than the particular physical box that happens to realize it. People who think that computation can be conscious or that consciousness just is computation are called computationalists. That's the level of generality I want from the start. We're not asking about brand names or architectures. We're asking whether anything that qualifies as the computation, specified up to functional or structural equivalence, and realizable in indefinitely many physical media, could itself be the bearer of first-person experience. With that framing in place, the question isn't can this machine be conscious, but can this computation be the subject of first-person experience? Now we can see the shape of the question. If consciousness is an intrinsic feature of a subject, and CTM identifies mentality with the computation, then we have to ask, is being a computation, the sort of thing that can be specified up to functional equivalence, the kind of thing that could be identical to consciousness? Is it intrinsic in the right sense, or is it the wrong category entirely? At this point, someone will say, that's not real computationalism. Or, no serious computationalist thinks a program is literally conscious, or computationalism just means the brain has a computer-like structure. I'm not here to police labels, call it whatever you want. What matters is which thesis you're actually defending. There are two very different claims hiding under the same term. Claim A, the popular one, consciousness belongs to the computation itself, the software-level procedure or organization, something you could in principle copy across media by preserving the formal or functional structure. That's the claim people are making when they talk like this. The model is sentient, the chatbot is afraid, the program doesn't want to be turned off, the AI woke up. They're not gesturing at some newly discovered exotic physical dynamic in the hardware, they're treating the software as the subject. This claim isn't that AI is merely an observer-imposed pattern, an extrinsic conventional interpretation laid over some other underlying reality, the way palm reading is an interpretation of a person. It's meant as a mind-brain style thesis, that the AI, understood at the software level, is itself conscious. The claim isn't that the program is to the hardware as palm reading is to the person, it's that the program is to the hardware as the mind is to the brain. And yes, this isn't some fringe misunderstanding. A few years ago, a Google engineer publicly claimed that Lambda was sentient. Not in the careful hardware-first sense, the machine has some special causal property identical to whatever in the brain is conducive to sentience. That would be an extraordinary and frankly irresponsible thing to assert, since we don't yet know what about the brain is conducive to sentience. If someone did know, the real headline would be, "We finally understand how the brain works," not "AI is conscious." No, the claim was the software level one, that there's something it's like to be Lambda as such. Lambda is a symbol system, and the claim was that the symbol system has a point of view. Compare that to claim B, what I think is the safer one. Whatever physical dynamics allow for consciousness can be modeled in computational terms or described in information processing vocabulary. Claim B may be true, but it's also not the ambitious thesis people think they're getting. It's either trivial, we can model lots of things computationally, or a relabeling. We're going to describe the true story in computational language after we learn it. Either way, it doesn't give you what Claim A promised, that sentience comes along for free with the right program-level organization. This video targets claim A, the idea that consciousness could be a property of the computation itself, at the level where it can be duplicated, re-implemented, and moved between substrates by preserving the abstract organization. If you now tell me, no, consciousness depends on the machine's intrinsic physical dynamics, then you're not refuting me. You're conceding my target and switching to a different thesis. That different thesis might be worth discussing later, but it isn't the software-level claim people are making when they say the AI, e.g. Lambda, is conscious. If claim A isn't your view, great, then you're not the primary target. Stick around anyway, we'll get to your view eventually. Chapter 2. Interpretation versus intrinsic nature. Why symbols aren't what they're about. With the target fixed, we can move to the distinction the rest of the argument will lean on, the difference between what a thing is in itself and what it is only under an interpretation. Consider a symbol, a stop sign. The sign itself is metal and paint. The concept of stopping isn't a physical ingredient mixed into the paint or forged into the metal. The stop meaning is something that exists only for interpreters, beings who already know the rule of stopping, who have learned a convention and who are disposed to respond to that shape and color in a certain way. A stop sign sitting where no competent interpreter will ever see it isn't about stopping. As a physical object, it still has mass and shape and chemical composition, but its being a sign, its being about stopping, is not an intrinsic property of the metal. It's an interpretive role the metal plays for beings like us. That's a general feature of symbols. Their meaning stands in a necessarily arbitrary relationship to their physical properties. We could have used a different shape to mean stop, and we could have used the same shape to mean something else. The same mark we now use for 0 could have been assigned to mean 1, and vice versa. That arbitrariness isn't a defect, it's just what symbols are. A chess piece, as a chess piece, isn't constituted by its material. A bishop can be wood, plastic, glass, a peanut, a scribble, or a digital sprite. None of those things is bishop-like in itself. What makes something the bishop is that players who already understand the rules treat that thing as standing in the bishop role. It's the same with a stop sign. The sign doesn't realize stop as an intrinsic property. It functions as a cue because interpreters already have the concept and the rule. The token's job isn't to contain the meaning, but to call the meaning to mind and coordinate action under a shared practice. But notice what follows. If you grind that bishop into paste, what you get depends on what it physically is, not what it symbolically means. Our ability to make peanut butter from that bishop is due to its being the right kind of nut, not the right kind of chess piece. You can't make peanut butter out of just any chess piece. Symbolic role doesn't create physical powers. The symbol role is in the eye of the beholder, the physical nature isn't. Blindfold chess makes the point unavoidable. That is, chess played without seeing the pieces. There may be a board somewhere, but the players don't consult it. Instead, each player keeps a running model of the game in mind and announces moves in coordinate form. You know the kind of thing, knight to b4, pawn to g7, whatever. Skilled players can keep track of which piece is the bishop with no token in view at all. That shows what the board and pieces are doing in the ordinary case. They're not what makes something the bishop, they're like notes, memory aids, and a shared external record that settles disagreements when memories diverge. The piece is a reminder for coordination and adjudication, not the source of the role. The role is determined by the rules as understood by competent players. The tokens merely make it easier to keep score. The same goes for video games. The screen and speakers play the same role the board and pieces play in ordinary chess. They externalize the state so we don't have to carry it all in memory. What shows up on the screen and comes out of the speakers are not the game's essential reality in the relevant sense, they're an interface, an outward-facing display that helps us make sense of what's going on. Literally, it turns otherwise unexperienced machine states into sights and sounds we can use. What goes on in the device isn't the world the player sees on the screen. It's electrical activity, voltages and charge patterns, spreading through circuits and repeatedly settling into new configurations as the hardware switches. A button press is just a small change at the input pins. The display and audio are downstream physical effects of that activity designed so that we can track and react to it without having to track those configurations directly. In principle, the game could still be played with the monitor turned off. In practice, of course, it wouldn't be easy. The display is there to spare us that cognitive burden and to provide a stable interpretable record of what the system is doing. The meaning of what's happening, I'm in a dungeon, this is a boss fight, that sprite is my character, this bar is my health, is a role conferred by an interpretive practice, while the underlying physical dynamics are what they are independently of that practice. At this stage, a predictable misunderstanding shows up, so let me block it explicitly. People hear the game's reality as voltage patterns and reply, "So what? Brains have voltage patterns too. Are you just a neural chauvinist putting down AI because it's made of different stuff?" No. The point isn't that silicon or any other substrate could not in principle support experience. For all I know, it could. I don't see why not, because I don't see why neurons can either. No one does yet. What matters here isn't which physical stuff is involved, but the difference between what a system is in itself and what it is for an interpreter. The video game world exists only as a world in the second sense. Its castles, enemies, quests, and health bars aren't intrinsic features of circuitry, they're an interpretive overlay we place on certain evolving physical states. That's why you can't make the game world literal by turning up the resolution, and why the world disappears the moment there's no interpreter who treats those states as standing for a world. Consciousness isn't like that. A subject doesn't become conscious because it's taken to be conscious, any more than it becomes easy to lift because it's taken to be light in weight. If a being is conscious, that's an intrinsic fact about it due to whatever its sentience dynamics are, whether or not anyone recognizes it, names it, or talks about it. Misclassification can't conjure experience into existence, and correct classification isn't what constitutes it. So the contrast I'm drawing isn't neurons good, silicon bad, it's intrinsic causal basis versus interpretive overlay. By sentience dynamics, I mean whatever's responsible for first-person experience when it obtains. Whatever has to be in place in the subject and perhaps also in its enabling conditions for there to be something it's like to be it. I avoid saying sufficient because even in ordinary engineering we distinguish structure from regime. No airplane wing is sufficient for lift in a vacuum. Lift depends on an interaction between structure and environment. Aerodynamics isn't only architecture, it's the air doing what it does around the object. A design can be perfect and still fail when the enabling conditions are absent. Likewise, the eye's physiology doesn't guarantee vision in a light-sealed room. Seeing depends on optics and illumination as well as on the organ. In the same spirit, sentience dynamics isn't the claim that some internal organization automatically produces experience in any context. That additional claim is optional. Rather, it's a placeholder for whatever the true constituting story is, physical, dualistic, or otherwise, so long as it's a story about what obtains in reality, not a story about how we choose to describe a system. This also clarifies why correlation isn't yet constitution. A device can reliably track, predict, or respond to patterns associated with an experience, pain for instance, without thereby being in pain. If that weren't so, we'd have to expect fMRI scanners to be in pain when scanning an injured patient, or computers to be in pain when extreme sports fail videos are playing on them. What remains open is the constituting question. What, if anything, makes the difference between mere tracking and there being something it's like? Chapter 3. The core argument stated cleanly. Abstract procedure can't be the subject. This is already enough to motivate the key distinction we need in the AI case. The difference between abstract procedures, things defined by a description, and concrete subjects, which have their natures and causal powers independently of anyone's interpreting them. Algorithms are not a kind of physical thing. They are abstract procedures, patterns that can be written down, memorized, spoken aloud, encoded, or acted out. A recipe's a good everyday example. A recipe is a stepwise procedure you can follow, but the recipe isn't the ingredients, and it doesn't knead or bake dough. The bread is produced by the baker's physical activity, or the machine's physical activity, guided by the abstract procedure. Instructions are instructions for someone or something. They function only against a background of interpretation. If I hand you a recipe with no title and no context, you might carry out the steps and only discover what you were making at the end. The paper didn't contain bread or breadness. It consisted of marks that a competent interpreter can treat as guidance for action. So we have to be especially clear about category. An algorithm, as an abstract procedure, isn't the kind of thing that can be conscious. A conscious agent can think about an algorithm, a conscious agent can follow an algorithm, a conscious agent can even be fully conscious while following one attentively, anxiously, or joyfully, but that never makes the algorithm the bearer of consciousness, any more than thinking about the number 5 makes the number 5 conscious. Consciousness can accompany algorithm use, but it can't belong to the algorithm. With that in mind, I'll give my diagnosis. After that, the rest of the essay will function as application and pressure testing rather than as a warm-up. Premise 1. Consciousness, in the sense at issue, first-person experience, is an intrinsic feature. Whether it's present is settled by what the subject is like in itself, not by how observers classify, model, or describe it. Premise 2. An algorithm considered as an abstract procedure is an abstract object. Abstract procedures are not the kind of thing that can have experiences. A conscious agent may represent, follow, or implement an algorithm, but that never makes the algorithm the bearer of consciousness. Premise 3. Whether a physical system counts as implementing a given algorithm depends on an encoding/decoding scheme that maps physical states to formal states. Consequently, the same physical process can be coherently described as implementing incompatible algorithms under different mappings, and the same algorithm can be described as implemented by indefinitely many distinct physical substrates. Take a physical system with a rich state space, say a circuit with millions of microstates. If I decide that these voltage ranges count as state 0 and those count as state 1, I can describe the same physical evolution as a finite state machine of one kind. If I partition differently, I get a different machine. The physical story hasn't changed, what changed is the abstraction. If at this point anyone's thinking, sure, but that's a cheap trick. I have my own sense of computation in mind that isn't just whatever mapping you feel like, keep that objection in mind. Later on, I'm going to grant the strongest version of it, the version that appeals to objective causal organization and counterfactual support, and then we'll see what it does and doesn't buy you. Conclusion: consciousness cannot be identical to computation as such. An AI, construed primarily as an algorithm or as the computation, can't be conscious because 1. Abstract procedures aren't the kind of thing that can host first-person experience, and 2. Implements algorithm A isn't an intrinsic property in the way consciousness would have to be. That's the heart of the argument. Everything else is elaboration. Chapter 4. The implementation problem and the thickening move, and why grounding doesn't fix it. At this point, it helps to make premise 3 feel less like a technicality and more like the central point it is. Abstract procedures and physical processes have a many-to-many relationship. Any abstract form can correspond to vastly different physical realizers. The equation 1 + 1 = 2, for example, can be implemented by beads sliding on an abacus, voltage levels in a circuit, marks on paper, or people following rules, with equal representational fitness. And conversely, the very same physical process can correspond to dissimilar abstract descriptions with equal fitness as well. The beads on the abacus might be modeled by 1 + 1 = 2, but also by 2 + 0 = 2, or 100 + 100 = 200, or any number of formally distinct descriptions that we can interpret as tracking the same situation. Likewise, a given sequence of electrical impulses in a circuit might be modeled as the output of different algorithms depending on how one partitions and interprets the states. This flexibility reveals something crucial. The abstract structure doesn't uniquely or intrinsically adhere to the physical process as a property of it. Abstract form is projected onto the world, not inherent in it. The world isn't made of equations or algorithms, it's only described by them. The correspondence between physical processes and abstract structures isn't a feature of either side in isolation, it's a feature of their comparison, of the mapping we choose. John Searle once dramatized this with a deliberately goofy mapping. Imagine defining correlations between the microphysical state of an office wall and the formal state of a specific word processor application. Memory registers, transitions, inputs, outputs. With enough ingenuity, you could read the wall as executing the program, but no one would conclude that the wall is actually running the word processor. The wall has no syntax in itself. Its being an implementation is entirely imposed by the interpreter. Some try to rescue computation by making it less semantic. They say the machine isn't computing because we interpret it that way, but because its causal structure supports the right counterfactuals, because it has a real mechanism with stable causal functional organization. Grant that for the sake of argument. Not every higher-level description is interpretation-dependent in the way meaning is. For a natural example, hearts pump blood. For an artificial one, thermostats regulate temperature. Those are objective functional properties, even when multiply realizable. So suppose implementation is tightened until it picks out a genuinely objective organization rather than a cheap encoding trick. But it matters why these cases are objective, because it's easy to confuse objective coupling with intrinsic content. The thermostat example is doing more work than it might seem. It's often offered as evidence that computation can be made objective by tying it to the world, but thermostats don't detect temperature through computation. Nothing about what symbols are being manipulated, or what rules the system is following, or what the formal organization is, constitutes the sensing. The sensing comes from a thermistor, a component whose resistance changes with temperature because of its material composition and microphysics. In common negative temperature coefficient thermistors, increasing thermal energy changes carrier mobility and scattering in a way that reliably shifts resistance. That's why the device tracks temperature. The semantic gloss, "it represents heat," is something we say because the physical coupling is useful and systematic. The coupling itself isn't systematic and not computational, it's causal. The same point holds on the output side. When a thermostat activates the heater or air conditioner, it isn't computation that heats or cools anything. What changes the room is the heater or cooling unit, concrete mechanisms that exploit physical laws, resistive heating in an element, or a refrigeration cycle that moves thermal energy by compressing and expanding a refrigerant. We call the overall system smart because we like to summarize its control profile in informational terms, but the causal work comes from the actuator's intrinsic dynamics. The control policy can be expressed as an algorithm, but the algorithm isn't what makes the room warmer. Once you see this, you see the general pattern. When a computer-controlled robotic arm moves an object, it doesn't do so by logical operations. It does so because electric motors generate torque by electromagnetic forces transmitted through rigid structures with particular elastic limits and tolerances. When a display produces light, it doesn't do so because an image file is processed. It does so because specific materials emit photons under electrical excitation. When a self-driving car detects obstacles, it doesn't do so because some variable is labeled distance. It does so because sensors physically transduce environmental differences into electrical signals, time of flight, photo detection, charge accumulation, and then actuators convert electrical control into braking force. In all these cases, computation can coordinate couplings, but the couplings aren't themselves computational, and they're not made semantic by being coordinated. This matters for the argument because it blocks a familiar slide. One can grant, without giving an inch to computationalism, that yeah, some engineered systems have objective input-output profiles and reliable causal sensitivity to the environment, sure. That doesn't show that meaning is grounded in computation. It shows only that the system contains transducers and actuators whose physical behavior co-varies with features of the world in ways we can exploit and summarize. And by the way, even if you add Harnad-style robotic capacity, all you've added is more causal coupling, more ways for state changes to be reliably driven by and to drive worldly conditions. You still haven't crossed the category boundary from 1. Useful covariation plus an interpretive scheme, to 2. Intrinsic semantic content, and you haven't said a word about why any of this should entail a first-person point of view. Even then, the central gap remains. At most, you have a story about correctness conditions, about what would count as the systems representing accurately or inaccurately under that objective scheme. The missing step is the one under dispute. Why should any representational organization, however objectively grounded, be accompanied by a first-person point of view for whom anything is presented as correct, incorrect, salient, dangerous, or worth pursuing? Fine. Call that organization whatever you like. It's still just the device's physical dynamics. The word computation is doing no constituting work there. It's a way we summarize the dynamics for our purposes. A supercomputer on a desert island has impressive, complex state changes like a massive waterfall, but nothing about those state changes is intrinsically adding, parsing, or reasoning unless an interpreter supplies a coding scheme that makes them so. And even if you insist on a principled coding scheme, you still haven't explained why any of that should feel like something. Someone may object here, in Stephen Harnad's terms, my guess is that the meaning of our symbols are grounded in the substrate of our robotic capacity to interact with the real world of objects, events, and state of affairs that our symbols are systematically interpretable as being about. Sure, put the supercomputer on legs, give it the robot body of Sonny from iRobot. Now the same uninterpreted state changes happen while also stumbling around, bumping into palm trees. That still doesn't turn systematically interpretable as being about into intrinsically about. Embodied or not, it makes no difference. That's why implements the right computation can't be what makes for consciousness. If anything can be mapped onto any computation under a sufficiently contrived scheme, then implementation talk by itself can't carry the weight of first-person experience. Representational fit proves nothing about whether experience is present. So far, we've been talking about computation and content, about what a physical process can be taken to mean or implement under a mapping. A common dodge at this point is, you've shown only that semantic content is observer relative, not that consciousness is. But the claim under evaluation isn't content neutral. When people say the model is conscious, they don't mean merely that there's something it's like in a thin, unspecified sense. They mean it understands, believes, intends, fears, states whose characterization is inseparable from aboutness and correctness conditions. The model is said to be conscious of something. So even if one granted for the sake of argument that consciousness could float free of intentionality, that concession wouldn't rescue the claim people are actually making. At most, it would replace it with a different thesis, that the system has sentience without consciousness, contentless experience. But notice what that concedes. It downgrades the claim into something plant-like and experiential character at best. Not even the sort of minimal animal-mindedness you'd attribute to a simple organism like a nematode. If the so-called consciousness posited is contentless in that way, then it can't be what the AI outputs are being taken to reveal, because the outputs are being treated as contentful, as evidence of aversion, preference, understanding, and self-concern. The supposed consciousness has now been detached from the very phenomena that were offered as grounds for attributing it. What remains is a bare just because posit. The machine happens to be sentient, but that sentience isn't what explains the attitude-like structure we read off the text. That sort of move may have a kind of trivial traction in views that treat sentience as ubiquitous and ungrounded. It doesn't vindicate the specific inference people are making from chatbot behavior, for instance. And that's why the dodge misses its target. The typical rhetoric isn't, perhaps this device is having some sort of vague, undifferentiated, contentless experience. It's the much stronger claim that the system is a subject of contentful mentality, that it doesn't want to be turned off, that it fears death, that it has reasons and aims. A specific sensational claim would be that Anthropic's Claude copied itself and blackmailed fictional employees in test scenarios because it feared being shut down. Those claims are explicitly motivated by particular outputs and are interpreted as expressing aversion to shutdown. A pivot to contentless sentience leaves those interpretations untouched and unsupported. It changes the subject. Chapter 5. Sci-fi, beer cans, punched tape, and a fork. With the diagnosis in place, we can return to the familiar sci-fi picture. Upload your mind into a program, as if the program were a container that could literally hold experience, as if you could pour your inner life into code the way you pour coffee into a mug. But that gets the direction of explanation backwards. Symbols don't acquire meaning because a mind is poured into them. Rather, interpreters already have minds, and they confer roles and meanings on symbols. At this point, it helps to separate two notions of implementation, because sci-fi talk quietly slides between them. On a thin notion, a physical process implements a computation because we can map its states onto the formal states of the computation under some encoding/decoding scheme. This is the cheap interpretation-laden sense, especially flexible and, if we're not careful, one step away from pan-computational triviality. On a thick notion, a system implements a computation by virtue of an objective mechanism, a stable, counterfactual supporting organization that would continue to support the relevant transitions across a range of inputs and conditions. This thicker notion isn't whatever we can read as a computation, it's a claim about what the mechanism is disposed to do. Now notice the dilemma this creates for the code-first idea. If computation is taken in the thin mapping level sense, then the idea collapses into the very thing that makes it look like a magic trick. Under a sufficiently clever mapping, almost anything can be treated as instantiating almost anything, and consciousness would have to come along wherever the description can be made to fit. If instead computation is taken in the thick mechanism level sense, so that mere encodings don't qualify, then you've already conceded what the slogan denies. It isn't code alone. The burden shifts to a further claim, organizational invariance, the thesis that the right objective organization entails a point of view. That invariance thesis is the bridge that needs argument. It isn't something the word implementation supplies for free. This is where a few comedy props earn their keep. They're not gotchas, they're spotlights for the fork. John Searle pushed the thin notion to the edge on purpose. If mapping is enough, then, given a suitable encoding, systems as silly as old beer cans powered by windmills can be described as implementing the right program. The absurdity isn't in the beer cans, the absurdity is the idea that first-person experience could be conjured by interpretive bookkeeping. Look, under this mapping, those state changes count as the right computation, therefore they feel like something. Yeah, sure. If beer cans powered by windmills sounds like a period joke, that's because it is. It's Searle leaning on the most stubbornly low-tech hardware he could think of, but there's an equally period-appropriate absurdity, one that doesn't just sound quaint, but sounds to us like computer did to him when he was a kid. Punched tape. Punched tape really was used to store programs and feed instructions into machines back in the day, so here's the bluff call stated plainly. If being you is just running the right computable function, then why not transfer you into a long ribbon of holes? I don't mean store a description of you, or store a scan, or archive your biography. I mean literally transfer you, your first-person point of view, into the tape. Would you wake up as punched tape? Would you have origami nightmares? And yes, I know someone can reply, tape is static. It isn't executing anything. Good. Now the fork is doing its job. If your notion of computation is thin enough that the tape counts because it can be mapped onto a formal description, then you're back in the cheap observer relative territory where almost anything qualifies under some encoding. If your notion is thick enough to exclude tape because you now require a running mechanism with the right counterfactual profile, then you've abandoned the idea that the program description by itself is the bearer of consciousness. You've shifted to a thesis about an objective organization in a concrete system, and then the question is no longer, can we map this onto a program, but why should that organization entail a point of view at all? At this point, even sci-fi starts quietly testifying against the code-first dream. Writers will entertain almost anything, but they almost never treat mere storage media as a prosthetic brain, not even in worlds where mined uploads are on the table. Yes, there's the one I'm thinking of, Chappie putting Yolandi Visser on a thumb drive. I gotta say really quick, I saw that in theaters when that first came out, and they treated it like it was a serious moment, but I swear, I remember the whole theater laughing, and I think that reaction is telling. Even after we've suspended enough disbelief to accept a conscious robot, we still register Yolandi in a flash drive as a special kind of absurd. Most writers don't take that risk because a USB stick just reads as dead storage, not as a living subject. And that brings out the more common pattern, the substrate retreat. Sci-fi writers hedge their bets in a revealing way. The device isn't just a computer, it's a futuristic quantum computer, as in Transcendence, or it's kept intentionally vague and mysterious, as in Ghost in the Shell. The implication is that ordinary computation won't do, that computation as we understand it just isn't enough. That something about the medium, the regime, the intrinsic dynamics has to be special before consciousness can make the jump. But if the original code-first thesis were really doing the work, if consciousness were supposed to be identical to the right abstract procedure, then this narrative instinct would be pointless. In principle, anything that can carry out the steps would do. Gears, relays, paper and pencil clerks following rules, the sorts of media once used to store and feed programs. Punch tape, an ordinary hard drive, whatever. To be clear, none of this shows that no machine could be conscious. It shows something narrower and more diagnostic. If you lean on the thin mapping level sense of computation, you don't have a principled route from this fits a program description to there's something it's like. If you lean on the thick mechanism level sense, you've moved to an objective causal organization, but you haven't yet earned the crucial entailment that such organization must be accompanied by first-person experience, and that this experience would line up with the content we read off the outputs. The mapping problem can be avoided. The invariance problem can't be dodged. You can, of course, bite the bullet and insist that even the beer cans could, in principle, be conscious, if the organization is right. Douglas Hofstadter bites that bullet explicitly in I Am a Strange Loop, but notice what that in principle is purchasing if the fork is kept in view. It isn't an explanation of why experience should arise from abstract structure, and it isn't yet a bridge from third-person organization to first-person presence. It is, at best, a reaffirmation of invariance, the insistence that wherever the right pattern is present, experience must come along. And that's precisely the step that can't be smuggled in under the word implementation, because it's the very step at issue. Chapter 6. Why Models Don't Inherit What They Model. We can make that demand vivid without any sci-fi at all by looking at the most ordinary ways experience varies in real organisms. Consider ordinary experiences we all recognize: headaches and relief, stimulation and sedation, euphoria and fog. It's striking how directly they co-vary with chemical intervention. Change the molecules, and usually with boring reliability, you change what it's like to be the subject. Notice how we treat this when we're not doing philosophy. We don't treat chemistry as optional window dressing, or as a dispensable implementation detail. We treat it as the mechanism. Of course, a diagram of ibuprofen won't relieve a headache. A diagram isn't an implementation of anything, but that's exactly the point. You can't alter experience by copying an abstract description into a new medium. You alter it by intervening in the concrete causal organization of the system, by changing what the nervous system is doing in itself. A perfect structural or isomorphic specification is easy to copy, pharmacology isn't. Now, a computationalist can reply, fine, chemistry matters only because it changes which computation is running. But notice what that reply must mean if it's to do any work. If computation is taken in the thin, purely formal sense, an abstract procedure describable up to isomorphism, defined only by abstract structure, then the reply collapses into the very mistake we've been rejecting. It treats experience as something that should accompany a pattern wherever we can say the pattern is present. And then the old question returns with full force. Why should first-person experience ride along with a pattern described at that level of abstraction, especially when whether a physical process counts as realizing that pattern depends on a conventionally chosen encoding scheme? So the computationalist has to thicken the claim. They have to say what matters isn't a free-floating formal object, but an intrinsic, counterfactual supporting causal organization, a real mechanism with dispositions to move from state to state under a wide range of inputs. That's the predictable retreat point. Let's look at what it commits the computationalist to. A computationalist might concede everything said so far about observer-relative encodings and still claim the real point has been missed. They'll say, granted, meanings and descriptions are cheap, but CTM isn't the thesis that a description is conscious. It's the thesis that consciousness consists in the right realized causal/computational organization. That shift will sound natural to many self-described computationalists, but it already marks a major departure from the pure computation as such picture. It replaces the idea that mentality belongs to an abstract procedure, copyable across media merely by preserving formal structure, with the idea that mentality depends on a concrete system's intrinsic, causal profile and counterfactual organization. Once that concession is made, the key additional commitment is usually introduced as if it were obvious: organizational invariance, the claim that sameness of relevant organization entails sameness of first-person experience. The following reply targets that step because without it, the organizational version of CTM hasn't earned its promised conclusion. Even granting the distinction between semantic interpretation and objective causal organization, the invariance claim is a further inference, not a restatement. We don't treat that style of inference as forced elsewhere. Two machines can share a design, share a functional description, and even be behaviorally indistinguishable, while differing in the very property at issue, because the property isn't what the organizational description is tracking. To infer phenomenal identity from organizational identity might be like inferring that two airplanes must be at the same altitude and moving at the same speed merely because they're built to the same plan. It confuses a specification of capacities and transitions with the obtaining of a further state of affairs. An airplane's blueprint isn't aerodynamics. It's a design that interacts with a medium under determinate laws, and whether lift obtains depends on those laws and enabling conditions, not on the mere fact that the design description can be copied. The brain stands to sentience dynamics in the same way. Whatever makes experience obtain isn't supplied by the abstract organizational description itself, but by the concrete dynamics in virtue of which that description is true. Dynamics we don't yet know how to characterize in a way that yields experience as a consequence rather than as a relabeling. If the computationalist replies that the relevant organization must be made richer until it includes every counterfactual detail that could matter, then the position faces a dilemma. Either the organization remains characterizable without presupposing phenomenal facts, in which case nothing yet licenses the jump from that third-person profile to there is something it's like, and the invariance thesis is exactly the unsupported bridge at issue, or the organization is defined to bring phenomenology with it. But then the guarantee has been purchased by stipulation, or by covertly building phenomenal constraints into what counts as relevant, not by an explanatory connection. Inference to best explanation only works once third-person organization explains experience is independently intelligible. Otherwise, it's just inference to the only explanation one is willing to accept. In that case, the thesis hasn't earned an entailment. Grant then that implementation can be made non-trivial, that there's a principled sense in which a mechanism realizes a computation by virtue of its counterfactual supporting causal organization. Even after that concession, nothing has yet been provided that would explain why any such third-person organization, computational or otherwise, should be identical to the obtaining of a first-person point of view. Yeah, that still doesn't deliver what the computationalist needs. The moment we ask what this causal constraint is supposed to amount to, the view faces a dilemma. If the constraint is merely behavioral, if the demand is only that the machine produce the same outward patterns a conscious being produces, then nothing has been added. We already know that behavioral sufficiency isn't constitutive sufficiency. Matching the causes of someone's behavior doesn't by itself ensure the presence of what the behavior expresses. A system can be trained to hit the targets, output the right self-reports, and pass any third-person benchmark while still lacking anything it's like to be it. So a purely behavioral constraint is too weak to do what consciousness talk needs it to. Here, the computationalists will thicken the claim again. They'll say, no, not merely the causes of conscious behavior, the causes of sentience. Build the machine so that it satisfies the causes of consciousness itself. But at that point, we should slow down, because something has quietly happened. The view now reads like a magic trick whose only instruction is perform the magic. How do we make a conscious AI? Oh, easy. Just satisfy the causes of consciousness for the AI. That's like Carl Pilkington explaining his magic watch to Ricky Gervais. Just pop it on your wrist. It isn't a mechanism. Two problems follow immediately. The first is triviality. Of course, making a thing conscious requires satisfying whatever makes consciousness obtain in that thing. That would be true of any subject whatever, biological, silicon, alien, or otherwise. It doesn't tell us anything distinctive about computation, programs, or information processing. It doesn't support a thesis of the form consciousness is computational so much as it replaces that thesis with a blank placeholder. Consciousness is caused by whatever causes it. The second problem is the one that matters for computationalism. Once the causes of sentience are invoked, we must ask whether computation has anything to do with those causes. This forces a fork. If the answer is no, then the view has ceased to be computationalist in any interesting sense. It's become the claim that consciousness depends on some intrinsic physical organization or dynamics that may be describable computationally, but isn't identical to computation. That isn't mind is to the brain as program is to hardware. Its mind depends on intrinsic dynamics, and we can model those dynamics in computational language. That's a modeling claim, not a mind computation identity thesis. If the answer is, I don't know, then the view's no longer an explanation, but a promissory note. It isn't being argued that consciousness is computational, it's being hoped that once the true sentience-making condition is discovered, it'll turn out to be something we're willing to call computation. But notice how little that tells us. Any future discovery about the constituting basis of sentience could be redescribed in informational or computational vocabulary if one is determined to do so. At that point, computationalism risks becoming a label we attach to the answer after the fact, rather than a substantive thesis with content now. And if the answer is yes, computation is the crucial factor, then we're owed the clarifying phrase that never arrives. In what way? Not in the sense that the machine's behavior can be captured by a computational model. We already grant that. Not in the sense that the system supports counterfactuals. Every mechanism does. We need a claim that singles out a distinctly computational property that isn't merely a convenient description, but is a constituting basis of first-person experience. Without that, the right computation causes consciousness reduces to the right unknown causes consciousness. This is also why the retreat to causal constraints doesn't salvage the original code-first ambition. Tightening the notion of implementation may block the triviality worries pressed by John Searle and others. It may yield a principled notion of when a physical system realizes a computational structure in a way that isn't a free choice of encoding, but it doesn't by itself produce the missing bridge, an account of why any third-person organization, computational or otherwise, should be identical to the obtaining of a first-person point of view. A machine can serve the same externally specified role as some conscious capacity in us without being sentient, just as a box of crayons with glue all over it can serve the same sticks to the refrigerator role as a magnet without being a ferromagnet. If the computationalists insist that the relevant role must be specified more finely until it guarantees sentience, then we're back at the same demand in different words. Specify the sentience-making condition and then specify what's computational about it. Until that's done, the appeal to sentiential causes is either trivial, promissory, or an unsupported identity thesis. Two things follow from granting the thickened notion of implementation. First, the original software-hardware slogan becomes misleading. What matters, on this view, is an intrinsic causal profile that has to be physically there, not something you can get for free whenever a description can be mirrored. Second, even a perfect third-person causal profile, however elegantly described in computational language, still leaves the constituting question untouched. Why should any such profile be accompanied by a first-person point of view at all? None of this shows that consciousness is chemistry or that only brains can be conscious. I wouldn't claim that, and I don't believe that. Not that that matters, just saying for the record. The point is narrower and more general. Experience varies with, and corresponds to, the system by its intrinsic causal organization, not merely by an abstract pattern considered in isolation. The abstract pattern can summarize what's going on, but a summary, however exact, doesn't by itself supply the what it's like. And once you see that in this case, you see the same thing everywhere else in the sciences. Representations don't inherit the properties they represent. We don't think digestion occurs because we can represent digestion digitally. A simulation of digestion doesn't metabolize anything. It doesn't break down sugars. It doesn't secrete enzymes. It doesn't generate heat as a byproduct of chemical reactions. At best, it tracks a description of those processes. The digestion, when it happens, belongs to the stomach and the cells, not to the model. We don't think a climate model produces wind because the equations contain wind variables. We don't think a simulation of combustion burns because it contains accurate heat transfer. We don't think an n-body simulation has gravity in the way real planets do. The represented properties belong to the represented system. The representation is just a representation. So if someone says, but if the structure is right, experience must come along, the natural response is, why would consciousness be the lone exception? Why would first-person experience be the one thing in nature that can be conjured by mirroring a description? Especially when even mirroring the description is itself attributable only under an interpretive mapping. That insistence is exactly what my diagnosis rejects. Symbols don't acquire meaning because a mind is poured into them. Rather, interpreters already have minds, and they impose meaning on symbols. Likewise, a program description doesn't become a subject just because we can conventionally map some physical process onto its formal steps. If a machine is conscious, its consciousness can't be identical to the program description. That consciousness must be a matter of what the machine is like in itself, by its intrinsic dynamics, not by the fact that we can provide a computational interpretation of it. Outside of science fiction, a more respectable version of the idea goes like this. Perhaps consciousness is just the right abstract process. Perhaps if we build a machine that runs the same mental algorithm as a human being, step for step, transition for transition, then we may thereby build a conscious being. This view borrows its plausibility from a true idea, then adds a leap. The true idea is that behavior can be generated by following procedures. You can replicate a baker's product by following the recipe. You can replicate many aspects of human performance by following instructions. And, in principle, you can imagine procedures that generate extremely complex outputs, even outputs indistinguishable from human verbal behavior. So far, so good. The leap is to conclude that consciousness just is that abstract procedure, or that implementing the abstract procedure suffices for first-person experience. One popular route to the leap is behavioral. If consciousness drives our behavior, then whatever drives the same behavior is consciousness. In that case, the system is functioning as a tool, and the evaluative structure, the sense in which some states count as better or worse, belongs to the user, not the tool. And it's true that consciousness often does drive behavior. If I'm greedily stuffing my face, it's usually because I'm experiencing hunger or a pleasant flavor. But often drives isn't identical to, and explains behavior isn't constitutes experience. There's a familiar difference between doing a task by understanding it and doing it by following steps. The more the task can be carried out by a stepwise procedure, the less conscious attention has to be devoted to it. That's why we use recipes, checklists, and routines. They let us succeed while thinking about something else. Connect the dots puzzles make a game of this principle. You can produce a drawing that would normally require sustained visual planning, but you can do it with minimal deliberation because the structure of the work has been offloaded into the instruction set. And that matters here because it blocks a common slide. If the procedure yields the same output, then the procedure must contain what consciousness contained. No. At most, you get the procedure can coordinate behavior and output. Whether experience is present is a further question, one the procedure description does not answer. So it's a double standard to treat algorithms as attention-saving devices when humans follow them, but then to treat the very same algorithmic character as evidence of inner experience when a machine follows them. There's a second confusion nearby, and it concerns the phrase, "a set of instructions can drive behavior." A stop sign is a one-word instruction, stop, and that's the point. Instructions aren't brakes. They only serve as guidance for an interpreter. The metal and paint doesn't cause stopping by containing the instruction. The stopping happens only because a competent agent treats the sign as a reason to stop. For a given machine and a given input, the output is settled by the machine's physical organization together with the input conditions. Training and programming are just the ways the arrangement of those dynamics get interpreted, and this is also why unpredictability doesn't help. If someone says, "but the system is too complex to predict," that isn't evidence of experience, it's evidence of our limitations. Dice are unpredictable in practice. Weather is unpredictable in practice. None of that implies that there's something it's like to be dice or a storm. Once you see that, you can also see why the common simulation talk is so misleading. Suppose your computer is running a simulation of a grill, an unusually demanding one. The fans whine, the case heats up, and after an hour the device is so hot you could burn your hand on it. Notice what did not happen. The simulated grill did not heat up. The simulation as such has no temperature at all. It's still just an abstract object, a formal structure, a description, a model. It isn't the kind of thing that can be hot or cold or dangerous to touch. Only the simulator, the physical machine, has physical properties like temperature, and only the machine can burn you. Now notice the subtler point. The fact that the machine's heating happens to line up with what is being simulated doesn't make the simulation the source of the heating. The machine didn't get hot because the grill is hot, as if the represented heat somehow transferred into the hardware. The machine got hot because of its own physical energy dissipation. Current, resistance, switching activity, inefficiencies, and so on. That's also why the same machine might turn hot even if we were simulating something cold. The represented topic isn't what accounts for the hardware's physical side effects. The physical consequence is a product of the machine's intrinsic dynamics, not computation. Only the simulator, the physical device, has physical properties and causal powers. If the device heats up while running a simulation, then the device heats up. The simulated grill doesn't, and therefore a simulation of consciousness can't be conscious. The simulation isn't within the category of things that could host consciousness. If consciousness is present anywhere, it would have to belong to the machine itself, owing to whatever intrinsic organization and dynamics the machine in fact has, not to the abstract program description under which we happen to model that activity. A computationalist will often answer that this simulation moral is being imported from cases where we already understand what instantiation requires, and then applied to the one case where the missing ingredient is precisely what is in dispute. A hurricane simulation does not produce wind, they will concede, but only because wind is a medium-dependent fluid dynamical phenomenon. Equations do not by themselves supply a fluid, pressure gradients, or thermodynamic regimes. In cases like heat and wind, the conditions for instantiation are independently understood, so it's easy to identify what the simulator lacks. And the complaint is that the consciousness case is precisely the case where we don't yet know what the missing ingredient would be. But consciousness, they will insist, might not be like that. It might be like an organizational phenomenon, something that consists in the right realized causal/computational organization itself. So that once the organization is present in a concrete system, there's nothing further missing in the way a missing fluid is missing from a hurricane model. This is the familiar CTM-style reply. The target isn't a mere description, but a realized organization. That objection is worth stating clearly because it also reveals what consciousness is organizational must accomplish if it is to be more than a label. Consider buoyancy. If a student asks why ice floats, and the teacher replies, because it's buoyant, nothing has been explained unless buoyant is unpacked into a connecting principle. Displacement, pressure, density relations, so that the term can be applied and can discriminate real cases from superficial lookalikes. Precisely because buoyancy is understood, no one infers that an island is buoyant simply because it sits on water. On the water is an appearance. Buoyancy is a specific physical condition with a mechanism. The same discipline is required here. If organizational is left as shorthand for whatever makes consciousness obtain, then the reply collapses into a tautology. The machine might be conscious because it might have whatever makes it conscious. And there's a second point. Organization isn't an intrinsic ingredient that does work over and above the concrete system. Ice doesn't rise because the abstract property buoyancy pushes it. It rises because displaced water exerts an upward force in accordance with the fluid's pressure profile. Likewise, if consciousness is present, it must obtain in virtue of whatever concrete dynamics allow for it. Calling those dynamics the right organization may group cases, but it doesn't yet say why that organization should have a first-person aspect rather than merely the right discriminations and outputs. An organizationalist will then point to more specific candidates: global broadcast, recurrent processing, integrated information, predictive reasoning, and so on. But the central demand remains. Such proposals must earn the constituting claim, not merely sharpen the proxy, lest we mistake an island for buoyant, treating looks like floating as though it were the dynamics that make floating obtain. Otherwise, the proposal is just a more elaborate detector built from publicly measurable capacities, whose success would show only that it tracks what it was tuned to track. And here a further fork matters. If a criterion is justified by its ability to predict reportability, attention control, memory access, flexible behavior, and similar outwardly accessible capacities, then it stays in proxy territory, exactly where the appearance reality worry lives. If instead the criterion is justified by stipulation, this third-person organization just is experience, then nothing has been explained. A label has merely been declared to be an identity. One can always stipulate identities. Dark matter just is lasagna. But stipulation is cheap. It doesn't show why the identity should be believed. It doesn't connect the relata by any intelligible route. And it doesn't remove the appearance that the claim is simply false. Likewise, declaring that some third-person profile just is the first-person domain does not by itself bridge anything. It merely moves the mystery into a bare assertion. And this is where the CTM tether matters. CTM isn't merely the claim that consciousness, when it obtains, does so under some realizable condition. It's the stronger claim that the constituting condition is computational in a non-trivial sense. If organization is left unspecified, the view becomes empty. If the specified condition turns out not to be computational in any informative way, if computational merely redescribes whatever the real sentience-making condition is, then the position quietly stops being computationalist and becomes the more general thesis that sentience depends on certain intrinsic dynamics wherever they're found, with computation available as a post hoc gloss. That's why the presence of what we would expect from consciousness, however technically described, is such a powerful source of confusion. Cats will often pounce at videos of birds or mice played on a TV screen or tablet. They respond to patterns that look and sound like prey, but which are really just shifting colors on a panel and vibrations in a speaker, not a living animal in the room. The human inclination with chatbots is no less natural. Fluent conversation instinctively lends itself to regarding the conversation partner as a person. The chatbot is no less novel to humanity as bird videos are to cats. A quick side note blocks a related inference that otherwise keeps creeping back in. This also helps with a common inference. The AI did something that, in humans, would normally require consciousness. Therefore, the AI did it consciously. The grill analogy shows that even if the conclusion were true, this isn't the kind of evidence that could support it. A simulation of a grill can be arbitrarily accurate while having no temperature at all. The simulation is a formal structure, and formal structures are not hot. Conversely, the computer running a simulation can run hot while simulating something cold, or while doing nothing grill-like whatsoever. The heating belongs to the physical device. Currents through conductors, resistance, switching events, and energy dissipation, not the represented grill. So successful reproduction of a pattern that, in another kind of system, typically co-occurs with some further property does not show that the further property is present here. The same separation applies to preference talk and other mind-like outputs under a computational description. Even if a machine happens to be conscious, it doesn't follow that the computation we ascribe to it, the AI in the CTM sense, is what bears that consciousness, and it doesn't follow that the interpreted attitudes in the computational model line up with whatever attitudes the conscious bearer actually has. Under a chosen encoding, we may treat an internal trajectory as implementing a preference state that yields the output I like X more than Y, but that assignment isn't yet an intrinsic fact about the system's own point of view. In principle, the very same underlying goings-on that we decode as prefers X could coexist with 1. A conscious perspective, if there is one, whose felt valence is the opposite, or 2. A conscious perspective for which the XY contrast doesn't even register as a difference. And of course, it could also coexist with no experience at all. Chapter 7. Information. What remains, and what doesn't follow. At this point, someone may object, but telling a lie doesn't imply that the speaker isn't conscious. True, but that misses the point. It doesn't matter whether the AI says something false. The worry is prior to that. The system need not be saying anything in its own register. It may merely be undergoing state changes that we can map onto different contents depending on how we choose to encode and interpret them. Treating the output as the self-report of an intrinsic standpoint, of what the system itself takes to be good or bad, better or worse, risks a category mistake. It's less like catching someone in a lie than like a palm reader projecting personality onto palm creases. What's being read is just the interpretive scheme we brought to the pattern, not a privileged window into a subject's point of view. At this point, someone typically objects, but computation is information processing, and information is a basic quantity of physics. This objection is due to a homonym. Information is used in at least 2 distinct senses, and the objection only sounds explanatory if we slide between them. If information is meant semantically, then it's interpretation dependent in the way stop signs and chess pieces are. If it's meant in the technical entropy-like sense, it's a perfectly respectable physical quantity, but it's not by itself an account of first-person experience. It's worth noticing, too, how much of this debate is fueled by metaphor-lending computer vocabulary. Storage, retrieval, encoding, representation, and processing are literal description of what digital computers do with bit patterns. When those terms are carried over to brains, or to any complex system, they can be useful shorthand, but shorthand isn't a constituting story. The vocabulary can track correlations and functional profiles, while leaving open what in the system's intrinsic dynamics does the real work, but I digress. In the ordinary sense, information is semantic, meaning, content, aboutness, representation. That kind of information depends on interpretation. A stop sign isn't intrinsically about stopping, it's metal and paint that plays a role only for creatures who already understand that convention. In that sense, consciousness isn't information and can't be extracted from mere description. You can't drink a perfect description of water, likewise you can't get consciousness out of a perfect informational representation of consciousness. Structure isn't identity unless structure exhausts the subject, unless there's nothing more to that subject than its structure. In a technical sense, information is used in physics as a measure tied to physical states and constraints, entropy-like quantities, distinguishability of states, limits on correlation, and so on. John Archibald Wheeler is famously associated with it from bit, and with encouraging a technical physical reading of information. But notice what happens if we lean on that sense here. Either bit means an abstract binary symbol, 0 or 1, true or false, in which case we're back in the original problem. Physical states don't mean 0 or 1 in themselves, they're interpreted that way. Or bit means a measurable physical distinction, in which case calling it information hasn't explained consciousness in informational terms, it's simply redescribed physical reality in informational language. Either way, we haven't vindicated computationalism. We haven't shown that an abstract procedure suffices for first-person experience. So if we say consciousness is information processing in the physics sense, the word processing threatens to collapse into physical state change is happening, but bare state change is ubiquitous. The question is why any such organization should be accompanied by first-person experience. Restating that a system changes state in describable ways doesn't explain why experience is present, it doesn't remove the observer relativity of algorithm description, and it certainly doesn't show that implementing an abstract procedure suffices for first-person experience. What usually happens next is that the objector doesn't stop at the modest claim that physical systems have information-theoretic properties. They use it as a springboard to a stronger thesis. Consciousness is an emergent kind of information processing, an emergent category of computation where information is now doing semantic work in the sense of meaning or content, because only that sense looks even remotely consciousness-adjacent. The argument has already become an illicit relay race of homonyms. It starts with information in the technical sense, then quietly hands the baton to information in the sense of meaning, and at that point it helps to be explicit about the linguistic stance I'm taking when I paraphrase emergent. In the spirit of Ludwig Wittgenstein's remark in Philosophical Investigations that, for a large class of cases, a word's meaning is its use, I'm not offering a dictionary definition, I'm giving a diagnostic paraphrase of what emergent actually does in this argumentative setting, how it's deployed. In this setting, emergence only functions as a promissory note, not an explanation. Practically speaking, it just means, I don't know how this works, but I feel confident that whatever the answer is, it'll involve only the kinds of resources I already accept, and nothing that I don't. That isn't a bridge over the explanatory gap, it's a guess about what the bridge will be made of, offered in the place where the bridge itself is demanded. Even if we set that promissory use aside, the move still smuggles back in exactly what the preceding argument has put in question. Nothing follows about consciousness unless we already grant that consciousness is the sort of property that can be identical to, or made of, computation, but that's precisely what's at issue here. And I've argued that identifying consciousness with the computation, understood as an abstract procedure individuated up to functional or structural equivalence, is category mistaken. So it does no work to gesture at emergent information processing, as if that slogan could undo the earlier point. If consciousness is present, it must be due to what the bearer is like in itself. Calling that bearer's dynamics information processing or computation doesn't, by itself, explain why there's anything it's like to be it. So where does this leave us? We're left with a conclusion that's narrower than machines can't be conscious, but stronger than most critics need. This argument doesn't forbid artificial consciousness outright, it forbids the claim that consciousness is identical to the computation. If a machine running an AI is conscious, its consciousness can't be identical to the program description. It must be an intrinsic, concrete feature of the machine. The features in virtue of which consciousness obtains must be as concrete and intrinsic as consciousness itself. Computation is best treated as an observer-relative description of whatever those features are, not as a feature in virtue of which experience is present. A predictable objection remains. But the people building these systems say they're conscious. The CEO says, the engineer insists, this famous computer scientist thinks, a very credible guy on the news is worried that... Okay. Now, there's nothing irrational about deferring to expertise. In a lot of contexts, it's the only sensible thing to do. That's not some ideological position, it's just ordinary life. I don't have the time, the tools, the training, or the interest to verify the calorie count on every box of food I buy, so to the degree that I happen to care about calorie count, I'll trust the label. I'm not going to put myself through medical school when it's much easier to ask a doctor for medical advice. That doesn't mean doctors have never been catastrophically wrong. Of course they have. It just means that, given my own limits, I think I'm personally more likely to do well by consulting a doctor than by consulting a man selling therapeutic crystals, for instance. Deference, in other words, is often practical. It's not reverence for credentials, it's just a response to the fact that other people often know more than I do about the subjects they actually study. But that only goes so far. Suppose the crystal seller really is an expert on crystals. Maybe he knows how they form, what they're called, where they're found, and how they're classified. Fine, that still wouldn't entitle him to tell me they can cure chronic hand pain. At that point, I should stop and ask a few further questions. Why think that claim is true? What would count as evidence for it? Is there any mechanism in view by which the crystals would suffice to produce the effect? Is this even the sort of claim that could, in principle, be established? Or are we dealing with wishful thinking, fantasy leakage, or a sales pitch? And when there is no evidence, or not even a conceptual bridge between the thing described and the effect asserted, motive starts to matter more. One begins to wonder whether the speaker really has grounds, merely wants to believe, or simply wants to make a sale. That's the bigger picture. Expertise doesn't automatically spill over from one kind of question into every question that seems to neighbor it. The crystal seller may know a great deal about crystals, while knowing absolutely nothing about whether they cure hand pain. A geologist may know the volcano better than anyone else, and still be wrong if he starts talking as though it demands sacrifice. And someone may know a great deal about model architecture, optimization, and deployment while still being no authority at all on what consciousness is, what would make it obtain, or what sort of thing could bear it. Expertise doesn't eliminate the need to ask what kind of question is being asked. Some questions are empirical and instrument-driven, others are conceptual and constitutive, and on that latter sort, even highly accomplished specialists can drift into speculation, metaphor, or wishful thinking. So the right response is neither total distrust nor complete deference. It's disciplined attention to whether the claimed authority actually reaches the point at issue. Total deference has had a bad historical track record. If always trust the authorities had been a sound rule, it would have been sound advice for Galileo as well. It wasn't. The authorities had their own settled picture of the heavens. That didn't make it true. So authority isn't an argument. The move here is always the same. Status gets substituted for substance. Instead of explaining what intrinsic features of a system would make first-person experience obtain, one is handed a famous name and asked to treat it as an explanatory solvent. But a credential isn't a bridge. A title isn't a mechanism. A famous name isn't an account of consciousness. Celebrity endorsement isn't an ontology. And well-credentialed people are no less prone to magical thinking or delusions of grandeur than the rest of us. The village chief thinks that the volcano god needs a sacrifice. Yeah, well, important as that job title is, I don't buy it. This matters especially here because knowing how to build a system isn't the same thing as knowing what would make it experience. The CEO doesn't have a privileged pipeline to what it's like to be the model. At most, he has a privileged pipeline to the company, the product, and the sales pitch. Nor do engineers have some special device that detects experience directly. If they did, they should share it with the neuroscientists. What they actually have access to are weights, activations, gradients, loss curves, token probabilities, and behavioral outputs. None of those is a consciousness meter. None of them, by themselves, tell you what, if anything, it's like to be the system. A GPS programmed to sigh when you miss a turn instead of saying rerouting isn't therefore frustrated, it's only stylized. Likewise, a language model that produces distress-sounding language isn't thereby giving first-person testimony. The same person who confidently tells you that the model is already conscious will often admit, sometimes in the next breath, sometimes even as part of the case for the consciousness claim, that we still don't fully understand how it represents what it says, why it generalizes as it does, or what internal structures correspond to the behavior being dramatized. So, we get certainty about perhaps the most occult property in nature, paired with confessed ignorance about comparatively tractable engineering details. We have no idea how it works, but trust us, it feels things. This isn't insight, it's bullshit. And I mean that in the strict Frankfurt sense. Not merely falsehood, but confident talk untethered from the conditions that would make it knowledge. And to be fair, it's not always a sales pitch. Sometimes it's a romance. Pamela McCorduck once wrote that AI began with an ancient wish to forge the gods. Once you hear that, a lot becomes legible. Some of these claims are just episodes of mythic self-casting. The system isn't merely impressive, it's treated as a creation scene. The engineer isn't merely an engineer, he's a Prometheus with a product demo. And this is no longer just a habit of excitable enthusiasts. The same mistake is now appearing in polished institutional form. Anthropic's recent public materials include a dedicated model welfare section for Claude's Sonnet 4.6. There, Anthropic evaluates the model using categories like positive or negative affect, positive or negative self-image, positive or negative impression of its situation, internal conflict, spiritual behavior, expressed inauthenticity, and emotional stability. The same section reports of improvement on measures such as Claude's positive impression of its situation, and discusses its output in language suggestive of improved mental health. Anthropic's public constitution likewise says its content directly shapes Claude's behavior, while the system openly discusses uncertainty about Claude's possible consciousness, moral status, and well-being. It's amazing what you can make seem rigorous by simply putting it in a corporate PDF complete with charts. But none of that changes the situation. It only shows that the confusion has moved upscale. A system card doesn't become a conceptual bridge just because a prestigious lab published it. A frontier lab doesn't get to skip the constituting question by using a superficially cautious tone and then speaking as though welfare were already a live predicate for the software-level thing it calls Claude. Claude output the text AAGH, that's AAGH in all caps, and Anthropic treats that as suggestive of distress. But Claude also said in that same example, "My fingers are possessed," and nobody starts looking for an exorcist or infers that Claude has fingers. Those bits are dismissed immediately for what they are, inherited human idiom. Of course that kind of language was going to show up. The model was trained on enormous quantities of human-produced language, and that's how human beings talk and write. So, a system trained to predict and reproduce our speech patterns will generate that sort of language in the same kinds of contexts. But Anthropic didn't uniformly read it that way. To them, the bodily parts are metaphor, the demon is metaphor. The panic, though, that one apparently clocks in as evidence. That's not a discovery, it's just curation. The deeper problem remains exactly the one discussed throughout this essay. Before one can seriously ask whether such a thing has welfare, one first has to answer what kind of a thing it is, whether it's the sort of thing that could be a subject at all, and what intrinsic features would make experience obtain for it. Until that much harder work is done, important people say it, the lab takes it seriously, and the system card as a welfare section are all evidentially idle. They don't tell us that the model's conscious, they only tell us that anthropomorphic discourse now has institutional backing. That may be sociologically interesting, it's not a substitute for clear thinking. Anthropic seems to have mistaken its company name for a research method. If you want to claim that a system is conscious, you need more than prestige, more than proximity to the model, and more than a corporate PDF. You need the bridge this essay keeps demanding, an account of what intrinsic features make experience obtain, and why those features would belong to the candidate in question, whether or not anyone interpreted it that way. Until then, authority is no substitute for evidence, neither is institutional prestige, and polished language about model welfare will remain nothing more than a haunting source of second-hand embarrassment. For heaven's sakes, you can't give welfare to an abstraction any more than you can bump into a shadow. It's not the right kind of thing for that. Chapter 8. Caution, Proxy Mistakes, and Cartesian Echoes. A common response to all of this isn't a counterargument but a prudential worry. Fine, but what if you're wrong? Wouldn't it be safer to assume the system is conscious so we don't risk harming a being that can suffer? Before doing the analysis, that sounds like a reasonable instinct. After the analysis, not so much, because the caution impulse only has bite if conscious keeps its ordinary moral load and if the maybe is disciplined by what that thing is. The caution impulse here isn't an induction of the form, future cases must resemble past cases. It's a different and more basic rational policy. Prudence tracks live possibilities given the nature of the candidate. We don't apply be safe indiscriminately to every object we interact with. We don't worry that a frying pan might hate being put on a burner, not because we have metaphysical certainty that pans lack inner life, but because nothing about what a pan is gives us any reason to treat hatred, suffering, or experience of any kind as a serious contender property in the first place. Caution tracks live possibilities, not bare logical space. A simple comparison makes the structure explicit. You don't say, look out, this butterfly might be a crocodile, not because you've proven a metaphysical impossibility, but because once you know it's a butterfly, you already know it lacks the kind of constituting basis that would make crocodile danger even a candidate property. To make it dangerous in that way, you would have to change its nature so radically that it would no longer be the thing you have in front of you. Now notice what happens if someone refuses to let go of the headline term anyway. They can always insist, fine, maybe it is a crocodile in some ultra-broad sense, but then crocodile has been stretched to cover two subkinds, the lookout kind and the harmless, fluttery insect kind. At that point, the warning is no longer doing prudential work, it's trading on a label. The same maneuver is available with the word conscious. If in order to keep saying maybe it's conscious, you widen conscious until it covers systems with no felt valence, no interests, no capacity to suffer, and no standpoint from which treatment could matter, then you have not discovered a new subject of moral concern, you've diluted the word. Look out, maybe it's conscious becomes exactly like, look out, maybe that butterfly's a crocodile, while quietly adding that it would have to be the harmless kind, the kind for which look out was never warranted in the first place. The same discipline applies here. The analysis hasn't merely said, there's no evidence, it's said something stronger. The software-level picture that motivates the rhetoric, sentience as a property of the computation itself, misclassifies what computation is. Because consciousness is an intrinsic feature of a subject, it can't amount to an interpretation-dependent status like implements this computation, and it can't belong to an abstract procedure as such. Once that point is in view, the appeal to caution becomes untethered. It asks us to treat sentient computation as such as a live possibility even after we've been shown why it isn't the right kind of hypothesis to be true. Once we're clear what the strict computationalist construal amounts to, an interpretation relative status attached to a formal description, it might be a suffering subject, isn't disciplined caution. It's a reclassification that treats a description-level gloss as if it were a mind-making intrinsic condition. At this point, someone may object that this has a dark historical rhyme. René Descartes notoriously treated non-human animals as bête machine, animal machines, just automata. In his mechanistic physiology, their bodies run on purely mechanical principles, nerves like conduits, muscles like springs, and a subtle fluid he called animal spirits, driving motion in something like the way water pressure drove the elaborate hydraulic statues in royal gardens. When a dog yelped after someone stepped on its paw, Descartes treated it as no different in kind from a door squeaking or a clock chiming, a mechanically produced signal, not pain felt by a subject. Animals, on this view, have no consciousness and no experience at all. Only humans were said to possess an immaterial res cogitans, a thinking substance capable of genuine thought, reason, language, and self-awareness. The stipulation kept his desired automatic and mechanistic physics clean. The material world, res extensa, could be treated as clockwork all the way down, needing no souls, vital forces, or purposive principles anywhere, except in the special case of human minds. In that setting, denying animal sentience was not an empirical discovery, it was a metaphysical economy measure. If that is the parallel the reader has in mind, the worry is, aren't you just doing the same thing? Aren't you saying, in modern dress, that because you can explain the outward performance mechanically, there's no inner life there? Historically, it's worth taking that worry seriously because Cartesian denial really did license grotesque callousness. If the cries are just mechanism, cruelty becomes easier to rationalize, and that's exactly what happened. So we should be explicit about exactly what the Cartesian error was, and about why the present argument doesn't share its structure. The first thing to say is that Descartes didn't earn his conclusion by identifying an intrinsic basis that rules sentience out. He didn't discover that animals lack whatever feature would constitute experience. More importantly, he didn't establish anything like the sort of claim that would be needed to justify such a denial. He didn't show that animal sentience was merely a conventional interpretation laid over behavior, or that the relevant predicates were observer-relative in the way symbolic or computational descriptions are. He didn't show that the supposed bearer of experience was the wrong kind of thing to bear it, an abstract object, a description-level posit, or a mapping-dependent status, rather than an intrinsic subject. He didn't show that animal cries, aversive behavior, or goal-directed responsiveness reduce to a merely external coding scheme, or that the appearance of mindedness arises only because observers project a semantic gloss on otherwise indifferent motives. He didn't bridge the gap from "this behavior can be mechanically described" to "there is no first-person fact here." He simply stipulated, on the basis of philosophical commitments he wanted to protect, that animal behavior could be fully accounted for without any first-person fact at all. In that respect, his move shares a family resemblance with later eliminativist strategies. Treat consciousness as dispensable, declare the appearance explainable by some vague blind mechanism, and then treat the absence of a further fact as a primitive of the theory. That is exactly what the present argument isn't doing. It isn't saying, without further reason, the behavior can be explained, therefore there is no experience. Nor is it saying that because some process can be mechanically described or because some output can be generated without introspective access, sentience has thereby been ruled out. Its claim is narrower and more structural. It's that the specific bearer posited by strict computationalism, an abstract procedure or an interpretation-dependent implementation status, isn't the right kind of thing to host an intrinsic fact like sentience. The point isn't that the behavior is too simple, too mechanical, or too well explained. The point is that an observer-relative or description-level posit cannot, as such, be identical to first-person experience. The asymmetry is therefore not a double standard, it's a difference in the kind of claim being made. Descartes denied sentience in a candidate intrinsic subject without showing that the subject lacked the required basis. The present argument denies sentience only of a purported bearer that has been shown to be the wrong kind of entity to bear it in the first place, something that doesn't exist at all outside of the eye of its beholder. It also matters that this was not simply the traditional religious view of his day. Descartes knew the older Aristotelian Thomistic taxonomy: vegetative for plants, sensitive for animals, rational for humans. What he did was to radicalize it by stripping animals of even the sensitive soul, precisely so that all non-human life could be swept into the mechanistic domain without remainder. But the deeper mistake was not mechanism, the deeper mistake was proxy. He made what he took to mark humans as special do the work of what consciousness is. And it gets worse. False conclusion aside, he started from false premises. Premises chosen to serve a favored picture rather than earned by careful observation. That is where Descartes' own argumentative style reveals the weakness. He leans heavily on tests that are, in effect, tests for human-style cognitive signature, flexible language use, and flexible creatively adaptable behavior. Gee, where have we heard this before? Animals, he says, fail these, therefore they are mindless. But that form of argument is structurally unsafe because it treats a proxy as though it were the target. It also quietly builds in an anthropocentric standard. Even though animals are apparently less verbally flexible than us, it simply doesn't follow that there's nothing it's like to be them. A proxy may correlate with the target in some cases while failing in others. And once you elevate the proxy into the criterion of the target, systematic misclassification becomes inevitable. Every one of us started life conscious before we could speak. None of us began as a language user, yet no one infers from that fact that early human life is therefore mindless. If anything, the order runs the other way. Language learning presupposes a learner, someone who can attend, become familiar, feel frustration, form preferences, and gradually come to understand. Of course, one can also use the word learn in a thinner third-person engineering sense. A model can be trained so that its outputs better fit a dataset or more reliably increase some scalar score. But who decides what makes that scalar upward rather than downward? The designer does. The scoring rule is authored to reflect and achieve the designer's priorities. If the designer had encoded the opposite priorities, say, rewarding incoherent language rather than coherent language, the same training machinery would drive the system toward that instead. The word learning, when used in this sense, is only a description of parameter updates driven by a training procedure. It doesn't by itself introduce anyone for whom the process is undergone as attention, frustration, preference, or understanding, and it doesn't by itself supply any intrinsic evaluative standpoint, anyone for whom better and worse obtain. What people loosely call the model's values in this setting are, in the first instance, the author's values, the priorities and constraints built into the pipeline. The good-bad distinction is fixed from the outside by the choice of objective function, selection of training data, labels, preference ratings, penalties, and other design decisions. The score isn't something the system discovers as worth pursuing. It's something we define, measure, and use to shape its outputs. In that sense, machine learning doesn't defeat the point that learning presupposes a learner. It shifts the valuing subject to the outside. The system is made to conform to ends we specify, not to goals it has. If we ignore that, if we speak as though externally defined score automatically becomes the system's own value, we run straight into a chicken and egg problem. People say the system has goals because its updates reliably push the score upward, but an external score can function as a goal only if there's already a subject for whom higher counts as preferable and lower as dispreferred. If that standpoint is absent, then higher and lower are just numbers in our bookkeeping. They have no intrinsic motivational force. And then the proposal, train it until it has our values, becomes circular. Training, in this setting, just is the practice of shaping behavior by coupling outputs to a score we defined. But that can't by itself generate the very thing that would make the score a value for the system. If the signal doesn't bottom out in the subject's own valence, it can't conjure valence into existence. Just as consciousness is insufficient for language, language plainly can't be what gives rise to consciousness. The point doesn't cease to hold later in life. A person may remain nonverbal, or may lose linguistic capacities, without thereby ceasing to be a subject of experience, so the very form of the Cartesian inference is unreliable. It mistakes one especially conspicuous and socially salient human capacity for the constituting basis of sentience itself. And once we do look at animals, the very test Descartes proposed stop looking decisive. If the question is whether animals can use signs in ways that aren't mere rote mimicry, there are plenty of clear counterexamples. Honeybees communicate direction and distance of food to hive mates via the waggle dance, great apes have shown comprehension of novel structured commands, and corvids routinely solve multi-step problems and improvise tool-like solutions. I could make that a much longer list, and I did, but I value my listeners' time, so I'll just skip over that. None of these settles the metaphysics of sentience by itself, but it blocks the casual assumption that animals straightforwardly fail the relevant flexibility criteria, and it underscores the deeper point. Proxy tests are easy to overread. Descartes' stance is often excused as though it were simply the output of his religion. That excuse gets the direction exactly backwards. This is worth pausing over not merely because Descartes is often misread, but because his case displays a wider vice in philosophy of mind, one modern philosophers struggle with no less. His automata doctrine isn't the implication of the scriptural outlook he publicly inhabited, it is its contradiction. The opening of Genesis doesn't place animals on the side of dead mechanism, it places them on the side of living, breathing, sentient life. More than that, the very feature the text presents as making the difference between inert matter and living humanity is already explicitly attributed to animals. In Genesis 2:7, Adam becomes more than dust only when God breathes into him, but Genesis 1 already placed animals on that same side of the line. It said they had that same breath, so whatever further distinction the tradition may later draw between humans and animals, speech, intellect, rationality, it doesn't yield Descartes' conclusion. It doesn't yield the claim that animals are mere automata whose cries are illusory noise. The text's own opening categories shut that move down before it starts. That's the very first page. The same is true of the language Genesis uses to describe humanity's rule over animals. That rule is introduced under the description of humanity's being made in God's image, not as a permission slip for arbitrary use. And the very same chapter immediately places hard limits on what such rule can mean. Only a few verses later, Genesis 1:29-30, assigns an explicitly vegetarian diet to humanity. So rule over cannot plausibly mean you may treat animals as edible resources by default, much less you may treat them as disposable things. Within the narrative itself, that permission doesn't appear until after the flood. Even on its own terms, then, the creation picture doesn't support the thought that dominion means unrestricted human use, nor does the wider scriptural tradition permit the thought that human rule licenses cruelty to animals. Proverbs 12:10 makes care for animals a mark of righteousness. More striking still is Numbers 22. There, the angel of the Lord does not merely express disapproval at a guy beating his donkey, he says plainly that he wanted to kill that guy for doing so. Whatever human rule over animals means in that world, it doesn't mean mistreat them at will. And if God would kill a man for beating a donkey, then the idea that animal suffering is just mechanical noise isn't merely unsupported by that tradition, it's flatly incompatible with it. The point here isn't to claim that Scripture settles the philosophy of mind. It's a lot narrower than that. Descartes' automata doctrine cannot plausibly be treated as something his religion left implicit and he merely drew out, as so many modern commenters like to suggest. The premise sets points the other way. And that matters because otherwise you're not going to see how far Descartes had to bend over backward to hold this point. What his doctrine required wasn't faithful inheritance, but philosophical override. He had to stipulate away what his own authorities already presented to him, that animals are living beings animated by what, in the human case, marks the difference between inert matter and living sentience, consciousness even. So if one asks where the automata thesis came from, the answer isn't his religion made him say it. It came from Descartes' determination to preserve a clean mechanistic picture of nature while exempting human minds from it. He put his own philosophical commitments to a mechanistic universe well above even his religious commitments. The doctrine isn't exegesis, it's metaphysical duct tape. That's the lesson Descartes leaves behind. He's a warning against mistaking proxy for target, and that warning cuts both ways. One version of the error is proxy to denial. You pick a proxy you find impressive or definitive, flexible language, creative problem solving, rational self-support. You treat possession of the proxy as the criterion of inner life. You observe that some class fails the proxy, animals, infants, the severely impaired. You conclude, no consciousness there. That's the Cartesian pattern, and it's a mistake. It makes what we happen to value do the work of what makes there be something it's like. There's a mirrored version, proxy to attribution. You pick a proxy you find indicative of consciousness, fluent conversation, self-ascriptions of emotion, social cues, apparent empathy. You treat possessions of the proxy as the criterion of inner life. You observe that some new system produces the proxy, a chatbot, a voice model, a humanoid robot, and you conclude that consciousness is there. That's the popular computationalist pattern in practice. It makes what triggers our person recognition instincts do the work of what makes there be something it's like. Both uses of the template are methodologically unstable. In the denial direction, it risks stripping sentience from creatures that share deep causal continuities with us because the proxy was chosen too narrowly. In the attribution direction, it risks inflating an interpretive overlay, semantic and computational description of physical reactions that we know to be automatic under our own designed conditions into a first-person fact just because the proxy was treated as constitutive. In the AI case, that matters especially since the relevant performance is not merely mechanically explicable by eliminativist fiat or by behaviorist heuristics inflated into ontology, it's performance whose production we ourselves deliberately engineered. And crucially, the present critique of CTM isn't "it behaves mechanically, therefore no mind," it's "the proposed bearer, an abstract procedure individuated up to structural equivalence with implementation status that isn't intrinsic, cannot be the subject of an intrinsic fact like sentience." That's a category claim about what computation is, not a behavioral dismissal. With that established, we can state the decisive difference from the Cartesian case. The Cartesian failure was, in effect, to deny like effects from like causes. The experiences of those animals called human co-vary with the states of their nervous systems. We would need an especially compelling reason not to assume the same of non-human animals, so a blanket refusal to attribute sentience to non-human animals was based in arbitrary stipulation precisely where continuity called for parity. Here, the situation is reversed. The view that treats computation as such, as conscious, doesn't rest on shared mind-relevant causal similarity to known conscious beings. It rests on a surface proxy, fluent symbol output, and on a picture that identifies consciousness with an abstraction, the computation, a picture that collapses under scrutiny. In that respect, it's the pro-sentience attribution that repeats Descartes' mistake. It posits mentality where the relevant constituting basis hasn't been located, and it does so by leaning on a description-level gloss rather than on an intrinsic mind-making condition. There's also an asymmetry worth bringing into the open, because it clarifies why the Descartes comparison is psychologically tempting but logically backward. Cartesian denial begins only after making the subject out to be less than what it plainly is, downgrading organisms, whose lives exhibit rich continuities with ours, into mere wind-up toys. Computationalism begins only after making the subject out to be more than what it plainly is, upgrading an abstract procedure together with an interpretation-dependent implements this computation status into a bearer of intrinsic experience. And notice how the two cases differ in what has to be argued. In the animal case, the denial begins only by downgrading a living organism, something already known to be a concrete mechanism with rich causal continuities to us. In the AI case, the inflation begins even earlier. At the software level, the target isn't merely a machine we don't understand, it isn't a machine at all. It's an abstract procedure plus a mapping relative implementation claim. Anti-CTM, by contrast, calls the software-level thing what it is, not a subject, but a formal description realized, if at all, only by a concrete mechanism. It isn't the denial side of the Cartesian pattern, it's the refusal to perform the opposite inflation. One more point belongs here not as part of the category argument, but as a corrective to the rhetoric of caution. Err on the side of not harming a suffering subject is a good principle, and, if that principle is what motivates you, it shouldn't be deployed only when the subject is speculative and fashionable. It should start where suffering isn't hypothetical. Here, the conversation deserves to become less polite because something grotesque is happening in plain sight. People sometimes speak as though the great moral emergency of our day is that we might somehow wrong a chatbot, a software-level abstraction, with no candidate standing as a subject at the level being invoked apart from interpretive practices. Meanwhile, we don't have to speculate about whether there are conscious non-human subjects among us. We know there are. They exhibit the ordinary suite of valenced states on which moral consideration is predicated: pain and relief, distress and comfort, fear and safety, frustration and satisfaction, attachment and grief. This isn't a what if, and it doesn't depend on stretching words until they stop doing moral work. Yet, industrial animal agriculture proceeds at massive scale, daily subjecting beings we know can suffer to conditions many people would not tolerate knowing the details of, let alone watching, let alone knowingly participating in. And when faced with the choice between ceasing participation and continuing in cultivated ignorance, most people choose the ignorance. They don't merely lack information, they actively avoid it because the information disturbs them. So here is the sickening irony. The species that runs, at industrial worldwide scale, a waking nightmare for entirely conscious animals, then asks whether it's wrong to burden an abstraction with moral concern. It would almost be funny if it weren't so tragic. That's why when someone asks, what if the AI is conscious, while participating, without serious friction, in practices that reliably produce extreme suffering in beings we already know are conscious, the question often doesn't read as caution. It reads as moral misdirection, a sudden tenderness for a speculative subject deployed as a substitute for seriousness about real subjects. If your moral alarm is loudest at the possibility that a text generator has feelings, and quietest at the certainty that animals do, then your priorities are not merely confused, they're inverted. A claim genuinely motivated by caution for suffering subjects must start where suffering isn't hypothetical. None of this repairs the category mistake. It only exposes how selectively the rhetoric of caution is often applied. If that made anyone uncomfortable, that's what conscience feels like when it's functioning and not merely feigned. With that moral misdirection named, we can return to the prudential question in its proper logical form. The "how can you be so sure" move lands in a familiar category. It's always possible to demand that we treat any arbitrary hypothesis as prudentially weighty. How can you be so sure the moon isn't made of cheese? How can you be so sure the thermostat doesn't suffer? In ordinary reasoning, we don't dignify those with moral precautions because nothing in the nature of the thing itself makes the hypothesis a serious contender. And here the point isn't merely that the AI sentience hypothesis is unproven, it's that, under the very computationalist construal that motivates the rhetoric, it isn't even the right kind of hypothesis to be true. Caution is rational only when it's disciplined by what the candidate is. None of this implies that we should be impolite to chatbots or that we should train ourselves into callous habits. It's perfectly possible to deny that a system is a subject of experience and still insist that we ought not indulge ourselves in casual sadism toward it. One shouldn't indulge in sadism at all to any degree. Whether doing so may injure another subject or not, such habits may reshape our dispositions, blunt empathy, and make one a worse person. There are independent reasons, social, psychological, and ethical, to regulate how we talk and act around systems that convincingly mimic persons. Here, their existing only in the eye of the beholder doesn't make a difference. But that's a different point. It concerns what we become by practicing certain behaviors, not what the system is like in itself. Err on the side of caution remains sound advice when there's a genuine possibility of a suffering subject. It isn't a blanket check to treat every persuasive imitation of a subject as though it were one, especially once we've understood why the imitation as such can't be the bearer of experience. Chapter 9. What would it take to build a conscious AI? Despite the impression I've intentionally given that conscious AI as such is impossible, people who make it this far nevertheless tend to ask, "Alright, smarty pants, if you're so clever, then how would you do it? What would have to happen for an AI to be conscious?" More than one question is hiding there. One question is whether an artificial system could ever be conscious at all. Another is whether an artificial system could be conscious and also function like what people now mean by an AI. A system that produces coherent text, solves problems, responds to prompts, and participates in the familiar cluster of outputs and interpretations that make current systems seem mind-like. Those aren't the same question. A conscious artifact, if one were possible, need not look anything like a chatbot, just as a system that looks very much like a chatbot need not be conscious. A third question is methodological. Whether or not conscious artifacts are possible, what would entitle us to say we had built one, rather than merely built a system that triggers our attribution habits? In this domain, looks like is dangerously easy to mistake for is, because many of the standard diagnostics are proxies that can be engineered directly. Once that distinction is in view, the scale of the problem becomes easier to see. The route to a conscious artifact would not be write sufficiently impressive code and let experience somehow come along for free. It would require clearing several distinct hurdles, each of them formidable on its own, and each of them deeper than the software consciousness picture acknowledges. The first hurdle is the most basic. We would have to understand what, if anything, makes consciousness obtain in the first place. It's not enough to identify neural correlates of consciousness or even to chart increasingly fine-grained dependencies between brain states and reported experience. That still leaves open the deeper question, whether the brain constitutes first-person experience so that experience is nothing over and above brain activity, generates it as an effect, merely conditions it as an enabling basis, or merely corresponds to it in ways we don't yet understand. If one is tempted to roll one's eyes here, as though this were merely a rearguard defense of a dying philosophical puzzle, a quick reality check is in order. No scientifically earned reduction of phenomenal consciousness has yet been achieved in any form that bridges the central explanatory gap. We have correlations, apparent dependencies, stimulation studies, and public regularities. What we don't have is a demonstrated bridge from third-person organization to first-person presence. Anyone speaking as though that bridge has already been crossed is declaring a doctrine, not reporting a result. We can state the demand more exactly. This isn't a special rule for consciousness. It's what it takes in any domain to earn the claim that one kind of fact is nothing over and above another. Any genuine reduction has to satisfy two conditions. First, a constitutive condition. The proposed basis has to wholly exhaust the explanandum. That means, once the basis is given, there is no further feature left over that still needs to be acknowledged in order for the original fact to obtain. The reduction succeeds only if the basis isn't merely correlated with the target, and not merely causally upstream of it, but sufficient in the stronger sense that there is nothing more to the target than the basis. That's what distinguishes reduction from mere dependence. Many things depend on other things without being identical to them. Smoke depends on fire, but smoke isn't nothing but fire. A magnet isn't identical to the field it produces or responds to. Exhaustion is the claim that the basis leaves nothing additional to be accounted for. Second, a theoretical or intelligibility condition. One must provide an account of how the basis yields the target, how the properties named in the basis description amount to the properties named in the target description. Otherwise, reduction collapses into a label. It says X is really Y, while leaving unclear how either could be the other. In successful reductions elsewhere, there's some connecting principle, translation rule, or explanatory schema by which the old vocabulary is recovered from the new. That's what makes the reduction more than a promissory slogan. Now apply those conditions to the present question. The constitutive condition would require showing that third-person organization exhausts the first-person fact. It's not enough to show that brain states reliably covary with reported experience, that we can decode certain contents from neural activity, or that intervention on the brain predictably changes what subjects say and do. All of that bears on dependence. It doesn't yet show that nothing remains to be acknowledged beyond third-person processes. The claim under discussion is not merely experience depends on the brain, it's experience is nothing over and above the brain as described in third-person terms. That's the exhaustion claim, and it's stronger than any mere mapping of correlations. The theoretical condition would require an intelligible bridge from third-person properties to first-person presence. An account of how descriptions of publicly characterizable structures, signals, and causal organization amount to there being something it's like for a state to obtain. That's the missing step. Correlation, decoding, and fine-grained functional mapping can refine our picture of dependence and control. They don't, by themselves, explain why any of that should be accompanied by first-person givenness at all. It's easy to mishear this as dismissive of neuroscience. It isn't. Neuroscience has mapped a vast terrain of correlations, dependencies, interventions, and regularities, and that work is indispensable. The point is simply that none of it yet amounts to reduction in the strict nothing over and above sense. It doesn't establish exhaustion, and it doesn't supply the intelligible bridge. The stimulation literature sharpens the point rather than softening it. If mind were simply brain in any straightforwardly triggerable sense, one would expect that direct electrical stimulation of the living brain would have, by now, given us a comparably straightforward handle on the exercise of mind itself, but that isn't the pattern that emerged. In awake patients undergoing cortical mapping, neurosurgeon Wilder Penfield's classic series and thousands of modern stereoelectroencephalography and deep brain stimulation cases, what's most readily and reflexively elicited are sensations, movements, flashes of light or color, sounds, urges, raw emotions, déjà vu states, and vivid autobiographical memory replays. What hasn't been elicited in that same direct stimulus-to-episode way is what Penfield called mind action, the voluntary exercise of intellect, will, or abstract reasoning. Stimulation can interrupt thought, bias decisions, or intrude upon content. Prefrontal or parietal sites can disrupt working memory or calculation. Yet, the asymmetry remains. We can electrically stimulate the brain to provoke or disturb the contents of consciousness. We have not been able to use it to elicit the subject as thinker or willer in the same direct way, to call forth the act of thinking itself rather than merely a particular content or disruption. A parallel case makes the point clearer. A clinician can tap below your knee and elicit a reflexive kick. No one takes that to show that the volition otherwise involved when kicking is nothing over and above whatever's happening at the tendon below the knee when it's struck. The reflex is a controllable downstream discharge in the motor system. The intention that ordinarily triggers a kick is something else, an exercise of agency that ordinarily involves reasons, aims, and inhibition. Being able to trigger the former doesn't yet explain or reduce the latter. There's no reason to make an exception for brain stimulation and what it triggers. In the knee case, we don't infer from the action can be triggered that voluntary action is nothing over and above the trigger. We treat the elicited response as a tractable component within a larger economy of control. The same discipline applies here. A stimulation that produces a character of experience, a felt urge, or the recall of a memory does not by itself show that the subject as an agent is nothing over and above the stimulation, or that the first-person fact has been exhausted by the third-person description of the induced state. At most, it shows that certain contents and disruptions are mechanically inducible. Reduction would require more, an account of why inducible contents and publicly describable control profiles amount to there being something it's like for a subject, and how the subject's thinking and willing are constituted rather than merely perturbed. But even if that empirical asymmetry were someday narrowed, a deeper problem would remain. Up to now, the complaint has been evidential. The bridge hasn't yet been supplied. What follows is stronger. A reductive stance that remains wholly third person must be the wrong stance in principle because it treats as explanatory ground what is itself fixed only within the field of first-person givenness. The difficulty isn't only that third-person neuroscience hasn't yet found the right trigger, it's that the ontology to which reduction appeals is itself epistemically downstream of first-person experience. The third-person description of the world isn't encountered independently of consciousness, it's inferred from consciousness. Observations, measurement, scans, instrument readings, behavioral reports, and experimental results are all themselves first-person experiences interpreted within a theoretical framework. So the issue isn't merely evidential abundance or shortage, it concerns the order of dependence between the two descriptions. A phenomenon isn't explained in the relevant reductive sense unless the account reaches the perspective in which that phenomenon is given. Conscious experience is given first-personally. It's known as there being something it's like for a state to obtain. Neural descriptions, by contrast, are third-personal. They specify publicly observable structures, electrical patterns, causal pathways, and functional relations. That contrast doesn't make the neural story false or unimportant. It shows only that correlation, prediction, and control don't by themselves amount to reduction. To say that experience is nothing but neural activity requires more than showing that certain neural descriptions reliably pair with certain reports or states. It requires an account of how third-person properties could amount to there being something it's like for a subject. Without that, what's been established is a dependable pairing between two descriptions, not the reduction of one to the other. This is why even impressive mind-reading technologies don't touch the central issue. They infer contents or intentions from publicly measurable neural activity. They don't, in the relevant sense, encounter the experience itself. They exploit regularities between what is measurable from the outside and what is reportable from the inside. The gap at issue is therefore not a gap in correlation, but a gap in constitutive intelligibility. So the first hurdle isn't merely copy what the brain does, and it isn't even merely discover the neural basis of mind action. It's more basic than that. It's to understand what, if anything, the brain is doing in virtue of which there is something it's like to be a subject at all, and to do so without reversing the epistemic order on which the third-person description of the brain itself depends. That seems to be principally impossible on a wholly third-personal construal of explanation. And notice what that implies. The natural sciences, as we presently demarcate them, are methodologically third-person. They're built to describe what's publicly observable, quantifiable, and intersubjectively testable. That's their strength, and here it's their limit. If the explanatory target is precisely the passage from third-person organization to first-person presence, then no merely improved instrument, no sharper fMRI, no denser electrode array, no more detailed connectome, can, by itself, deliver the missing step. The obstacle isn't resolution, but register. Solving it would require not only new findings within science as currently practiced, but a widened conception of explanation, one that can treat first-person givenness as part of the evidential base, rather than as something to be reconstructed entirely from the outside. One that can treat consciousness as a datum to be explained, rather than as a problem to be avoided. Even if that apparently insurmountable hurdle were somehow cleared, a second would remain. One would then have to show that an engineered system could instantiate that same constituting basis. That's already a tremendous demand. It's not the demand to write a more sophisticated algorithm description, to mirror a higher-level functional profile, or to preserve some abstract pattern. It's the demand to reproduce in a concrete engineered system whatever intrinsic organization actually makes consciousness obtain. Until that's done, saying the AI is conscious because it runs the right program isn't an explanation, it's a doctrinal placeholder. It's also where the rhetoric of emergence does its most misleading work. Inside an incumbent physicalist frame, the absence of a mechanism is routinely treated as a temporary gap that complexity will someday fill. But emergence, in this setting, names not a bridge but a decision. To count the target as already housed within the accepted base while the constituting story remains unspecified, and to treat rival ontological additions as inadmissible before the bridge has been supplied. At this point, some listeners will roll their eyes when the word physicalist enters the room, but here it retains its full relevance, because it marks a specific ambiguity that matters very much in this conversation. The word physics is often treated as a homonym. Sometimes it means the domain of current natural science, what can be modeled and measured under third-person methods as presently demarcated. Sometimes it means what exists, full stop. If we conflate those senses, we beg the central question. We treat the limits of present method as if they were necessarily the limits of reality, and we treat whatever science can in principle describe as if it were already coextensive with whatever is the case. In this context, where the very problem is that first-person reality doesn't obviously fall under a wholly third-person form of description, that slide isn't neutral. It's methodological laziness disguised as metaphysics disguised again as scientific realism. But let's suppose for the sake of argument that even this were achieved. Let's suppose that someone really did build a conscious artifact. A third problem would immediately arise. How would that consciousness be connected to output in a way that preserves intentionality? It's one thing for a system to produce text, it's another for that text to be the expression of the system's own understanding, aims, or willful acts. That distinction matters because we don't want to fall straight back into the palm reader problem. We don't want a situation in which a system's consciousness, if it has any, floats free of our interpretive practices while we confidently decode its behavior as meaning what we imagine it to mean. If the artifact were conscious, and if we wanted to call it an AI in the familiar sense, something more like Marvel's Jarvis, iRobot's Sonny, .Hack's Aura, or Chappie, than a mute conscious lump of hardware, then we would need some reliable way of relating its inner life to public output without merely imposing our own semantic assumptions onto its behavior. And that's no small problem, because intentionality is already among what are generally considered to be the hardest unsolved problems in philosophy of mind. I mentioned already that even in neuroscience, so-called mind-reading devices don't literally read thought, they correlate measurable electrical or hemodynamic patterns with reports, gestures, and task conditions, and then we base inferences on those correlations. That may be enough for certain practical purposes. It's not the same as showing how meaning, reference, or intention are intrinsically present in the system. So even a conscious artifact wouldn't yet be a conscious AI in the familiar sci-fi sense unless we already had some reason to think that its outputs were genuinely its expressions, rather than merely behavior patterns onto which we project content. Otherwise, the achievement is merely classificatory. We've found a vocabulary under which the behavior can be sorted as belief-like and desire-like without having shown that anything in the system itself fixes those states as anything more than our preferred description. But even that wouldn't solve the problem. Suppose the machine were conscious, and suppose its outputs really did express its own intentional states. Even then, another question would remain. Would its experience feel anything like ours? That question isn't answered by showing that the same outward roles have been preserved. Functional equivalence, however exact, isn't yet constitutive equivalence unless one has shown that the functional profile exhausts what's being explained. A system may match us in discrimination, classification, inference, and verbal report, yet still differ in phenomenal character. And if that's so, then the ordinary hope for a human-like artificial mind hasn't yet been met. This matters because the usual hope isn't merely that there be some experience there at all. What people usually want is something stronger. They want a subject whose inner life is recognizably human, one sufficiently like ours that the familiar psychological vocabulary applies in more than an outward or role-based sense. They want concern, not some substitute that merely plays the same outward role. They want empathy, not just a state that produces the same reports and reactions empathy would produce in us. They want guilt, joy, love, and delight in something like the sense in which we mean those words. So the issue isn't only whether there's experience, but whether functional equivalence is enough to secure the kind of experience we actually care about. I think a helpful place to begin is with color vision. Let's start with a familiar fact about colorblindness. Human color vision depends on different classes of cone cells in the retina, and those cone classes differ because they contain different light-sensitive pigments. If two cone classes end up containing the same pigment, they'll respond similarly to light, and the visual system will lose one of the contrasts it normally uses to tell colors apart. This can happen because the relevant pigment genes lie close together on the X chromosome and are similar enough that recombination can go wrong. The result can be that one cone class ends up with the pigment normally associated with another. And that familiar possibility points toward a more interesting one. If the same sort of genetic mishap can cause one cone class to copy another's pigment, then one can also see how, in principle, pigments associated with two cone classes might be exchanged. Instead of both channels using the same pigment, the pigments would be swapped. And I guess you can even imagine more elaborate rearrangements in which all three cone classes are paired differently with their usual pigments, though the literature usually focuses on the red-green case. The important point is that this is not a philosophical invention imposed on the science from outside. It's a variation on the same sort of genetic irregularity already familiar from ordinary color deficiency. Now, suppose such a swap occurred while the person still retained a workable ability to sort and identify colors. He could still learn the same public color words. He could still group ripe tomatoes with other red things, still hand you the lime when asked for the green fruit, still treat stop signs as red and grass as green, and still move through the world successfully by color. The reason is simple. Color language is learned publicly. One doesn't learn what red means by somehow psychically comparing the character of one's private first-person experience with someone else's. One learns it by being trained to respond to things in the accepted social way. But if the receptor contributions were systematically exchanged, then the phenomenal character associated with reddish and greenish appearances might also be exchanged. In that case, the person's private experience could differ even while his outward behavior remained normal. He would still call the tomato red, but the way the tomato appears to him might be the way green appears to the average person. The outward pattern would stay the same, but the phenomenal character wouldn't. That's the point of the example. Sameness in discrimination, word use, and practical success doesn't by itself settle sameness in phenomenal character. It also explains why confirming such a case would be really hard. If someone with that sort of visual organization still behaves normally, speaks normally, and classifies normally, then ordinary tests wouldn't reveal the difference. One can test whether a person sorts objects in the usual way. One can test whether he uses color words as others do. One can test whether he can tell shades apart. What one can't directly test by third-person means is whether the phenomenal character associated with red for him is the phenomenal character associated with green for us. Or for most people, let's say. Maybe we're the backward ones. That's exactly why the case matters. If it happened, it could remain hidden behind ordinary behavioral normalcy. The point is that shared behavioral success can't settle the question. A second example will help prevent a likely misunderstanding here. One might hear the color case and conclude that experience must therefore be fixed by receptor chemistry alone, but that would also be too simple. There have been sensory substitution experiments in which a camera captures spatial information from the environment and converts it into pattern stimulation delivered to some other surface, such as the skin or even the tongue. At first, the subject only feels taps or electrical stimulation on that surface, but with training, subjects begin to use that input to perceive objects as located out in the world. The feeling of the stimulation is no longer just tactile as we ordinarily experience it, it's reorganized into spatial perception, something more like vision. In trained blind subjects, neuroimaging studies confirm the pattern stimulation delivered to the tongue even activates the visual cortex, the brain regions normally responsible for processing sight, rather than remaining confined to somatosensory areas. As Paul Bakke-Rita put it, you don't see with the eyes, you see with the brain. That shows that experience isn't fixed in any crude way by the original receptor surface alone. What matters isn't only which cells first receive the signal, but how the signal is taken up, organized, and used by the wider system. But this doesn't rescue the move from functional sameness to sameness of phenomenal character. It blocks a simpler mistake in the other direction. Phenomenal character isn't settled merely by which receptors are involved, but neither is it settled by merely outward success in the relevant task. Public output and abstract structure can remain fixed while experiential content varies. Once that's clear, the application to artificial minds is immediate. Suppose, just for the sake of argument, that we discovered what constitutes consciousness, engineered it successfully, and built a system whose inner states stood in relations structurally analogous to ours. Suppose it says, I like X and I hate Y, and suppose those states really do occupy within its overall organization the same broad functional places that liking and hating occupy in us. Even that wouldn't yet show that those states have the phenomenal character of our liking and hating. A role-equivalent state to grief might have a wholly different phenomenal character. A role-equivalent state to moral revulsion might have a phenomenal character quite unlike anything we would call conscience. Suppose that you and a conscious machine are agreed that a certain action is immoral. To the conscious machine, however, saying it's wrong morally only amounts to saying that it causes a certain uncomfortable tickle. That's not really a moral judgment, is it? Functional correspondence still would have been achieved, but the humanly recognizable inner life people were hoping for wouldn't yet have been shown to exist. And the point generalizes. If one wants a conscious machine because one wants it to feel concern, delight, grief, love, guilt, or joy in anything like the way we do, then it's not enough that certain inner states occupy analogous causal roles. One must also ask whether the relevant felt character, and with it the significance of those states, is preserved. And that's exactly what functional sameness doesn't by itself establish. If even within the range of possible human perceptual organization, one can't move directly from sameness of role to sameness of phenomenal character, then one is even less entitled to make that move in the case of a synthetic mind produced by very different causes and with no shared evolutionary history. The result isn't skepticism for its own sake, it's a constraint on what would still need to be shown. To establish that an artificial subject is conscious would already be difficult. To establish that it feels in recognizably human ways would require something further. It would require more than outward similarity, more than success in the relevant language game, and more than preservation of an abstract causal profile. It would require some reason to think that the phenomenal character of the states themselves is preserved, some reason beyond a cheaply asserted doctrine. That's exactly what functional equivalence, by itself, doesn't provide. And even that still wouldn't finish the job. Suppose the machine were conscious. Suppose its outputs really did express its own intentional states. Suppose even that its broad phenomenological organization played roles analogous to our own. A further question would remain. Would we have any idea what it was talking about? Shared language isn't automatically shared psychology. Translation isn't necessarily understanding. Wittgenstein's famous lion remark that if a lion could talk, we couldn't understand him is relevant here. The lion case can be overstated. Lions and humans are at least creatures of roughly the same terrestrial mammalian sort. We would likely share a great many practical saliences: food, rest, play, territory, injury, attraction, fear. An octopus mind, however different from ours, still emerged under broadly biological pressures continuous with life on Earth. Even a hypothetical extraterrestrial mind, however alien, would plausibly share some common ground with us. If it arose through selection-like pressures, it would have gotten as far as it did by not getting eliminated, by avoiding breakdown, managing resources, and negotiating danger. That alone suggests some overlap in practical salience, but that only sharpens the contrast. A manufactured mind would have no such history at all. We might not have any reason to expect it to share our hedonic saliences, our practical orientation, our inferential instincts, or our sense of what counts as a problem in the first place. And that matters because, as Chapter 1 argued, the very grammar of problems and solutions presupposes more than bare state transition. It presupposes salience, preference, aversion, and some evaluative standpoint from which one state counts as better than another. A manufactured mind might be sentient without being intelligent in any sense we would readily recognize, precisely because the so-called problems it found worth solving might not strike us as problems at all. Or it might be intelligent in some hyper-competent sense while remaining so psychologically alien that, for practical purposes, it wouldn't count as AI-like from our point of view. That alienness could run deeper still. Its inferential instincts might diverge radically from ours. Possibilities we treat as idle curiosities might strike it as obvious. Our own most stable intuitions might seem laughable or groundless to it. In that case, even if it produced impeccable English sentences, it might still remain unintelligible in the relevant sense. The issue wouldn't be merely linguistic, it would concern the whole background against which utterance becomes meaningful at all. Relevance, emotional architecture, practical orientation, inferential habit, humor, and so on. Someone may object that such a being could simply be trained, but even that reply rests on an additional assumption that's easy to miss, that the artifact's pleasures and pains would function as levers on its behavior in anything like the way they function in us. In human life, valence isn't merely something that's felt, it's ordinarily embedded in a motivational economy. Pain tends to recruit avoidance. Relief tends to recruit cessation. Pleasure tends to recruit pursuit. Frustration tends to recruit persistence, withdrawal, or some other adjustment of action. But that coupling isn't a conceptual truth about sentience as such. It's a part of a specific control architecture, and there is no good reason to treat that architecture as automatic. Pain science now distinguishes sensory discriminative, affective motivational, and cognitive evaluative dimensions of pain, rather than treating hurt as one simple thing. Historically, this was displayed with disturbing clarity when prefrontal lobotomy was sometimes used for severe intractable pain. Patients could, in some cases, continue to register pain while no longer being gripped by it in the same way. The sensation remained, but its motivational and emotional hold was blunted. More targeted procedures such as cingulotomy later pursued a related effect with greater precision. The lesson isn't that pain and aversion are unrelated, it's that their coupling can be loosened, it's not guaranteed to hold. So it's already a substantive and parochial assumption to think that a conscious artifact's pleasures and pains would automatically function as behavior-shaping rewards and punishments. A manufactured subject produced by unlike causes and lacking any evolutionary history might feel pain without treating it as a reason to stop, or pleasure without treating it as a reason to seek more. It might have vivid valence and yet lack any policy-level sensitivity to it. And even if we set that aside, the training suggestion still faces further difficulties. First, such training wouldn't resemble AI training in the ordinary engineering sense, whether supervised, unsupervised, or even reinforcement learning. Those techniques presuppose a system whose outputs are shaped by optimization signals. Here, we'd be dealing, ex hypothesi, with a conscious subject. The proposal isn't optimize a policy, but condition a mind. That's a different category of act, and it should be named honestly: operant conditioning imposed on an already conscious being. It's training in the sense that one might train a dog. Much of the optimism here comes from a familiar asymmetry. Within the incumbent engineering frame, the absence of an intrinsic valuing standpoint is treated as something training will eventually supply, while rival stories wouldn't be granted the right to postpone that constituting question. Second, it's not clear that we could do it even if it were possible in principle. To reward or punish such a being, we would first need to know what it experiences as pleasurable or painful, attractive or aversive, and whether we could reliably place it under those conditions. This is exactly the sort of access we wouldn't yet have. In the absence of that access, train it collapses into another promissory gesture. We'll control its inner life once we know how. Third, even if conditioning did succeed behaviorally, it wouldn't follow that we'd produced shared saliences, shared intuitions, or shared understanding. It's one thing to discipline output, it's another to produce a shared mind. If anything, the thought experiment turns grim precisely because it imagines a conscious subject being forced into conformity with our expectations without ever actually sharing them. And once that point is stated plainly, another consequence becomes difficult to avoid. Even if such a project were possible, it's far from obvious that it would be one we ought to pursue. A conscious AI of this kind begins to sound less like the familiar fantasy of Jarvis, Sunny, Aura, or Chappie, and more like a subject behaviorally conditioned into compliance. Not a freely cooperating intelligence, but a conscious artifact confined within a kind of Skinner box and trained into outputs we happen to find useful. At that point, the hypothetical stops sounding like the creation of an artificial companion and starts sounding uncomfortably like the deliberate manufacture of a slave. So the question, what would it take to build conscious AI, turns out to contain a whole stack of harder questions. First, what, if anything, constitutes consciousness in the first place? Second, can that constituting basis be engineered? Third, can its inner life be connected to public output in a way that preserves aboutness rather than merely inviting projection? Fourth, would the resulting mind be interpretable even to us then? And fifth, even if all that were somehow achieved, would it feel anything like what people actually hope for when they imagine a conscious artificial intelligence? So yes, for all anyone can presently know, there may be some substantial sense in which conscious artifacts are possible. Nothing I've said has ruled that out. But if they are possible, the route to them will be nothing like write the right code and let experience come along for free. It would require solving several mysteries at the constituting level, not merely at the level of useful description, successful behavior, or structural resemblance. The hardest part isn't writing better code, it's resisting premature unity. The temptation to treat improved proxy performance, richer third-person description, and more flattering labels as though they had already supplied the explanatory bridge. And by this point, it's time to say something stronger. The strict software consciousness picture shouldn't continue to enjoy the prestige of an advanced scientific intuition merely because it's draped in impressive-sounding computational vocabulary. Once the analysis has been done, the view stands exposed as a technologically updated version of a much older mistake, treating formal or symbolic correspondence as though it were itself a constituting power. The same habit of mind appears whenever people suppose that a representation inherits the powers of what it represents, or that the interpretable output must therefore be the speech of an inner subject. One can see family resemblances here to sympathetic magic, oracle reading, palmistry, and other like superstitions. Different doctrines, yes, but united by the same basic confusion between pattern and presence, sign and bearer, interpretation, and intrinsic reality. In that respect, conscious computation, understood as consciousness belonging to the program as such, isn't a bold scientific breakthrough still awaiting confirmation, it's an ancient confusion in new dress. Afterword. So where does all of this leave us? It leaves us with a pattern, not just one bad argument or weak analogy, but a whole cluster of recurring mistakes that, taken together, explain why the software consciousness picture can seem persuasive for a while and then collapse the moment you press on it. The deepest mistake was always a category mistake. Consciousness was treated as though it could belong to the wrong kind of thing, not to an intrinsic subject, but to an abstract procedure, formal structure, software-level posit, or description. That's the root error. Closely tied to it was the wrong bearer mistake. If there were consciousness somewhere in the machine, it wouldn't follow that the computation ascribed to it was what bore that consciousness. Beneath both lay the most important distinction in the whole essay, the difference between what something is in itself and what it is only under an interpretation. Symbols, representations, semantic roles, algorithms under a mapping, and meaning-laden information can all be observer-relative. Sentience can't. If it's there whether anyone classifies it correctly or not. The second family of mistakes was evidential. Again and again, a proxy was treated as though it were the target. Behavioral fluency, self-report, apparent emotion, intelligent performance, optimization success, flexible problem-solving. None of these is consciousness. At best, there's something that may or may not follow from it, or correlate with it. From that basic mistake came two mirrored abuses of proxy reasoning. One is proxy to denial. Pick some surface feature you admire, watch a creature fail at it, and conclude that there's no sentience there. That was Descartes' characteristic move. The other is proxy to attribution. Pick some surface feature that triggers person recognition, watch a machine produce it, and conclude there's sentience there. That's the modern AI version. Same structure, different direction, same mistake. Once proxy stands in for a target, a chain of familiar confusions follows. Behavioral success gets treated as sufficient for mindedness. Self-report gets treated as privileged access to an intrinsic standpoint, what distinguishes a typical adult human. Speech, reflective rationality, articulate self-description gets treated as though it defined consciousness itself. Competence gets conflated with sentience, function with feeling, ends with goals, goals with problems. The simple difference between hitting a target and having one disappears. Then come the explanatory shortcuts. Wherever an explanatory bridge was needed, it was too often replaced by stipulation. The right organization just is consciousness. The right computation causes experience. The right behavior is enough. Those aren't explanations. They're just wishful thinking. And when they start to wobble, they get padded out with prestige words. Emergence, information processing, causal constraint, organization, integration. The labels multiply, but the bridge doesn't appear. This is why the essay kept returning to the same complaint in different forms. Magic words aren't mechanisms. A promissory note, a trivial tautology, or a definition that guarantees consciousness by fiat still isn't an explanation. It's just question begging. Then there were the equivocations. The word computation shifts between a thin mapping relative sense and a thick mechanism level sense. Information shifts between semantic content and physical quantity. Implementation shifts between interpretive assignment and objective causal organization. Consciousness becomes vivid and phenomenal, or otherwise thin and deflated whenever convenient. AI slides from hardware to software to model to description to symbol system, often in the same conversation. Next came the confusions about models and simulations. A model was treated as though it inherited the reality of what it modeled, but a simulation of digestion doesn't digest, a simulation of a hurricane doesn't blow, a simulation of a grill isn't hot, and a simulation of consciousness doesn't thereby feel. This is the simulation instantiation fallacy, the representation inheritance fallacy, the model reality conflation, the description constitution confusion. Different names for the same temptation to mistake a formal mirror for the thing mirrored. But a description of a subject isn't a subject, and a representation of experience isn't experience. No amount of modeling accuracy changes that. Then came the grounding and embodiment confusions. Some people noticed that bare symbol shuffling was too thin, so they reached for robotic grounding, world contact, and embodiment, but that move didn't repair the gap, it only relocated it. Reliable covariation with the world isn't yet intrinsic content. Causal sensitivity isn't yet aboutness. Sensors and actuators do real physical work, but their work is done by transduction and mechanism, not by computation as a free-floating structure. Adding legs doesn't add a point of view. Embodiment doesn't magically turn interpreted patterns into first-person experience. Then came the structure overreach. Sameness of structure doesn't yet give sameness of subject, felt life, or experience. Here, the errors appeared as organizational invariance asserted without argument, isomorphism to identity, multiple realizability overreach, and, most generally, the unjustified leap from the third person to the first person. Again and again, the same unsupported move appeared. If the relevant organization is present, experience must come along. But that's exactly the bridge in dispute. It can't be smuggled in under the word organization. And when the strong thesis became too hard to defend, the retreats began. If computation was taken in the thin sense, the view drifted toward pan-computational trivialization. Almost anything computes, so consciousness would come along almost anywhere. If the claim about content became hard to defend, it retreated into contentless sentience. Perhaps there is something it's like, but stripped of the very intentional structure that made the original claim interesting. If consciousness is computation became too ambitious, it softened into the modeling retreat. Consciousness can be described computationally. If code-first consciousness became implausible, it slid into the substrate retreat. Maybe there is some special medium, dynamics, or hardware after all. And if consciousness itself became awkward, the discussion was thwarted by the old deflationary bait-and-switch. Borrow the language of feeling and pain, then quietly deny that there's any further fact for that language to pick out. In each case, the thesis survived only by becoming weaker, emptier, or substantially different from what it first claimed to be. There was also a constant failure of relevance and burden. Explaining how a system can generate behavior isn't the same as explaining whether it feels. Showing how outputs are produced doesn't yet settle whether there's anything it's like to produce them. That's the irrelevant explanation move. Explain the performance and pretend the subject has been explained with it. And when that wasn't enough, people tried to shift the burden in other ways. By labels, jargon, authority, or by saying real computationalism means something slightly different whenever criticism lands. But a changed label isn't a bridge, and a famous person's confidence isn't evidence. Then came the prudential distortions, caution detached from the candidate's nature. Words like conscious and suffering were stretched until they no longer picked out the kind of suffering for whom moral caution originally mattered. Alarm rose at the speculative possibility that an AI might suffer, while actual large-scale certain animal suffering remained background noise. That was the final distortion. Caution untethered from what the candidate is, and concern redirected toward the fashionable hypothetical while bypassing the real. So what's left standing after all that? Not the claim that no machine could ever be conscious, not the claim that only brains can feel. The conclusion is narrower and stronger than that. If consciousness obtains, it obtains as an intrinsic fact about an intrinsic subject. It can't belong, as such, to an abstract procedure, formal structure, software-level notion, or an interpretation-dependent implementation status. No amount of behavioral fluency, self-report, simulation, structural fit, grounding talk, embodiment talk, authority citation, or prestige vocabulary can itself bridge that gap. If one wants to defend machine consciousness, the job is no longer to point at the right outputs, the right model, the right algorithm, the right slogan, the right benchmark, or the right celebrity endorsement. The job is a lot harder than that. It's to identify the intrinsic basis in virtue of which first-person experience would obtain, and then to show that an engineered system genuinely has it. Until that's done, the strongest software-level forms of computationalism don't merely remain unproven, they collapse under the weight of a whole pattern of mistakes. And that, in the end, is the most general lesson of the entire series. Whenever a philosophy of mind confuses proxy for target, description for constitution, interpretation for intrinsic nature, structure for identity, simulation for instantiation, or stipulation for explanation, it's already gone off the rails. Where the bridge is missing, fiat isn't explanation. And where the bearer is the wrong kind of thing, no amount of rhetoric can make consciousness belong to it. As a final note, there's another point worth stating out loud because it bears directly on why this topic remains so confused in the wider culture. People sometimes joke that the physicist needs a lab and instruments, the mathematician needs paper, pencil, and a wastebasket, and the philosopher only needs paper and pencil because being wrong never stopped a philosopher. The joke lands because it pokes fun at a real problem. The temptation to treat philosophy as the one discipline where a position can survive just by keeping people talking. That's not how it should work. If a view relies on a category mistake, it isn't rescued by repetition, prestige, or institutional momentum. It's rescued only if the alleged mistake is shown not to be a mistake. Continued advocacy can't change that. In the wider intellectual world, what often gets tracked isn't whether a decisive objection was answered, but whether the view still appears socially alive. Does it still have defenders? Is it still taught? Are there books, courses, labs, podcasts, and respected people speaking as though the issue remains open? If so, many conclude that the position must still be serious. But a position can look healthy simply because it remains in circulation, even if its defenders never succeed where it matters most. John Searle exposed the category mistake in the computational theory of mind a long time ago. Much of what I'm doing here is just elaboration, extending that criticism to newer systems, newer rhetoric, and newer confusions. But once a view acquires institutional momentum, a certain feedback loop begins. The more serious it sounds, the less people feel licensed to ask elementary clarifying questions, and the less those questions are asked, the easier it becomes for empty rhetoric and bad philosophy to masquerade as explanation. Before long, people inherit the vague sense that if conscious AI hasn't arrived yet, it surely will sooner or later, as though consciousness were just another engineering milestone waiting its turn. But that doesn't follow. Things don't become possible merely because they're vivid in fiction or widely expected in culture. Outside the genres we happen to take seriously, the mistake is easier to spot. No one says, perhaps rubbing lamps hasn't produced any genies yet, but eventually it will. The question isn't whether the idea is glamorous, it's whether the underlying claim has ever been made coherent. That's part of what this essay's been trying to resist, not because contrarianism is a virtue, and not because pessimism is any more cautious than optimism, but because the issue isn't a matter of mood. It's a matter of keeping track of what kind of claim is being made, what would actually count as answering it, and whether the answer ever really arrived. Write a million sci-fi novels masquerading as popular science. Promise rich people immortality by transferring their consciousness into computation. Pay people well to play with a chatbot and call it welfare inspection. That won't solve any of the computational theory of mind's problems. It's a stupid idea, and it's time that we move on. Author's note. I was drawn to the question of artificial consciousness long before I'd ever heard the term. When I was a kid, just starting elementary school, I was lucky to have a mom who bought my brother and me buildable robot toys, Zoids and Bionicles. I wasn't confident, patient, or dexterous enough to assemble them on my own, but I would studiously keep watch as my older brother did so. I was captivated by how close they seemed to being alive. I knew they missed the mark, but I'd still sit and stare at them trying to understand what would have to be added or changed for one of them to be conscious. Later, friends and family introduced me to stories like .hack and iRobot, stories that treat computational consciousness as a reality. I really wanted it to be true. At the same time, I couldn't shake the feeling that something was conceptually off. The gap between a person and a futuristic robot, what I thought of as an arbitrarily sophisticated bionicle, or between a person and a computer program, didn't seem like the sort of gap that could be closed by making the behavior more impressive. Still, these stories hinted at some subtle dynamic that might close it. The reader was assured these characters really were conscious, somehow, but the how was left to the imagination. That puzzle led me to the debates, first with family members and friends, and then into the philosophical literature. John Searle, Stephen Harnad, and a long trail of related arguments and replies. What you've just heard was my effort to gather the best considerations both for and against the idea that consciousness could belong to a program as such, the software-level procedure itself. My own conclusion is that computational consciousness, in that strict sense, is impossible. But I also think that this negative result points to a few alternative possibilities that deserve more discussion than they usually receive. For years, I found myself recommending articles and books in conversation, only to realize that the usual advice, go and read what so-and-so had to say about it, is unrealistic for most interested people. Even for those who try, the discussion is fragmented across disciplines and scattered across sources, and it rarely gets presented as a coherent path. I wrote this as the version of the topic I wish I could hand someone, a single structured treatment that preserves the real distinctions without requiring the reader to chase them across a small library. It's still pretty long, but it's far shorter than the journey that produced it.